everyone. How are you all doing? I am Aditi, your physics teacher, and we have started this mega live today of physics for class 10th. Let me know in the comment in the live chat if I'm visible and audible properly. It is going to be a crazy session today because we are going to solve 100 PYQs of all the chapters of physics for your class 10th. Let me know, mark your presence in the live chat and let me know if we can start the session or not. Hi everyone. Hello everyone. Today is a big day for us, for your class 10th physics. Right, so let me know when, give me a thumbs up if you all are ready for this session. We are going to see a lots of questions today, from easy to hard, from MCQs to numericals to conceptual questions, everything in this single package. Hi Rifkat, hello. Okay, can we start this session now? Can we start with our very first question of the day? Okay, let's start with the very first question, and the question says, it is in CBSE 2022. It says, we'll read the question. First of all, there are some ground rules for this life. You have to solve every question very carefully. Take a back seat, sit properly, calm yourself down, and then read the questions. Okay, we are not in a hurry. Even in your exam, do not hurry, do not panic, because that creates panic, right, and anxiety, and that's why you are not able to solve the questions properly with your full potential, right? So keep yourself calm, drink some water, and let's start this live. Okay, we are with the first question, that is, list the factors on which the resistance of a uniform cylindrical conductor of a given material depends. List the factors on which the resistance, we have to read the question very carefully. Starting with, we have to list the factors, that is true, on which the resistance of a uniform cylindrical conductor. So basically I want to tell on what factors the resistance depends, right? And we know the formula of resistance, we have crammed it by now, right? The formula of resistance is what? It's simply R equals to rho L divided by A, where rho is my resistivity, correct? R is the resistance, L is length, and A is area. So on what factors resistance depends? It depends on resistance, depends on what? It depends on resistivity of that material, resistivity of that material, correct? And then what else is there in the formula? In the formula we have length, right? That is, then resistance also depends on length of that conductor, length of that conductor, right? Here we have a cylindrical conductor, so the length of that cylindrical conductor is also responsible for the resistance, right? Understood? Give me a thumbs up if you understood. We are taking it very slowly from the very basic, right? Then it also depends on area of, not just area, this is not just area, it is what? Area of cross section of that conductor, area of cross section of that conductor. Understood? Easy, very easy question. We are done with the first question. We've just started our live, and we'll do all the questions from all the chapters, right? Conceptual, numericals, everything, right? So understood this part? Every time someone asks you on what factors anything depends, the resistance, the resistivity, try to first remember the formula, right? Try to first remember its formula and whatever then there is in the formula. So I can clearly see resistivity is there, length is there, area is there. So on those factors my resistance will depend. Correct? Hi Sachin, how are you? Okay, we are done with our very first question. Can we move on to the next one? It's just morning. I want your Josh high. You have done your breakfasts, right? Okay, let me know, and I'll in that time we'll move on to the next question. And the next question says the resistance of a wire of 0.01 radius. Now again, whenever we are studying a numerical, whenever we are reading a numerical, first obviously read it carefully, but the one thing we are going to do, we are going to write everything that is given in the numerical. Correct? So the what is given? Resistance of wire of radius 0.01 centimeter. So radius is given. Correct? The radius is given as 0.01 centimeter. Clear? Is it visible properly on the screen? Is it visible properly? Just let me know in the live chat if there is any problem. Correct? Okay, so resistance is now given as 10 ohm. So okay, so write this as radius, and resistance as 10 ohm. Correct? Then if the resistivity of the wire is also given 5 into 10 raised to power minus 8 ohm meter. Correct? Understood? So resistivity of the wire is also given. Resistivity is 5 into 10 raised to power minus 8 ohm meter. These are all the stuffs that is given to us. Correct? Now we have read the numerical properly, and we have written everything whatever is given to us. Right? Till that, any doubt? Then find the length of the wire. So we have to find the length of the wire. Easy. Hi bachcho. Hi blogger. Okay, so we are doing this numerical. Study this properly. Resistance of wire of 0.01 centimeter of radius is given. The resistance is 10 ohm. If resistivity of the wire is 5 into 10 raised to power minus 8 ohm meter, then find the length of this wire. Correct? Again, very simple. We know, ma'am, we know the formula of resistance. Everything is given. What is the formula of resistance? R equals to resistivity into length divided by area. Right? Now it is a wire, so its area of cross section will be pi r square. For a wire, the area of cross section will be pi r square. Understood? That much we know. Right? Now I have resistance, that is 10 ohm. Correct? Equals to rho is also given 5 into 10 raised to power minus 8. Correct? Length we have to find. Understood? Now area. Now radius is given, pi value I know, but there is a very big mistake here if you don't correct the SI units. See, resistivity is in ohm meter, right? Resistivity is in ohm meter. Hello Zarina, we are solving this numerical. Okay, let me know if you know the answers in the live chat. We are solving this numerical from the very basic. What we did? Now area is pi r square. So pi I can write, r square is in centimeter. So I have to convert it in meters first. This is a very important step. Do not miss this. We have to convert this in meters first. So I can just multiply. This 1 centimeter will be 10 raised to power minus 2 meters. Correct? So 0.01 centimeter will be 0.01 into 10 raised to power minus 2 meters. Correct? And can I write this as 10 raised to power minus 4 meters? Very easy conversion. Very easy conversion, okay? Okay. Now this, the radius, the value of radius is 0.0001 meter. That's it. That is 10 raised to power minus 4 meters. Understood? So I'll put that here, 10 raised to power minus 4 whole power square. Understood? Everyone clear? Let me know if you have any doubts. Let me know if it is not clear, okay? And also let me know if it is clear. right? Okay, so I can just solve for the value of length now. 10 into pi is 3.14 into 10 raised to power. Now this is 4 into 2 minus 8 and divide by 5 into 10 raised to power minus 8. Understood? This will clearly be your length. Hi, good morning Bunty. Understood everyone? This whole concept, this whole everything is clear. Now you can just solve this. This is a calculation, keep it in mind. You have to do the calculation very carefully, right? Do not run through it. So this 10 raised to power minus 8 and this cancels out. Understanding? Now length is what? 31.4 divided by 5. Correct? Which we can do. 6 is 30 and then 14 will be 0.28. Correct? Do it very slowly, okay everyone? So length comes out to be 6 point C. Now what will be its units? Since we have converted everything in meters, see here, meters, ohm, meters, so the units will be also meters, and this is my final answer. Correct? Let us, this is my final answer. Okay, everyone clear with this part? Hi Bishan Kumar, hi Afreen. Okay, everything is clear with this part, everyone? Any doubt? If you have any doubt, just ask in the live chat, okay? Right hai, Bunty is saying thank you. Okay, can we move to the next question? Give me a thumbs up if you understood everything till now. See, these numericals are very important for your boards, right? Okay, clear. Bunty is saying ma'am. Yes, what ma'am? What I was saying is, these numericals are very important. These are basics, but see, they have come in boards. This is a CBSE 2022 boards question, right? So you just have to remember the basic formula, okay? Understood? Is my video clear, right? Okay. Okay, let's move on to the next question. Next question says, oh, this is also a previous year question. Okay, now read it carefully. What we have to do? Find the current flowing through the given circuit. So we have to find the current flowing through the given circuit. But what is the twist in this circuit? They have not just given us the voltage or just a resistance. They have given us multiple resistances, right? They have given us so many resistances, and the resistances are in parallel and are in series, so we have to use our brains, okay? Yes, so what we have to do in this case, we'll go step by step, right? Okay, yeah, okay Bishan Kumar, I'll try. Okay, so what we have to do, we have to go by step. Okay, so the very first step, first we have to find the equivalent resistance. See, there are so many resistances in this circuit. What we have to do, we have to combine, we have to find an equivalent resistance. We have to combine kind of all these resistances into one. So the first is find equivalent resistance. Correct? This is the first step we have to do. Then what we have to do? Two answer hoga. Okay, we'll see, Bunty will see if you are correct or not, but let's go through this, okay, calmly. Fine. Then what we have to do? Now see, which circuit do we look first is the real question, right? So the first is this parallel one. Why? Because these are in series. You cannot add this 2 ohm, you cannot add this 2 ohm with this 6 ohm, right? We have to firstly solve this parallel combination so that it gets in series with the rest. Okay, So what we have to do, we have to solve this parallel combination first. What we'll do, let's just name these. Let's say this is R1, R2, R3. Yes, you can do it without naming, but if you name it, it will reduce your chances of making an error. Okay, so finding equivalent resistance is my first step. So what will I do? I'll go in R2 and R4. What I'll do, 1 by R2, 4. Why I used this formula? Because this is a parallel combination. Okay, Rifkat is saying 8 ohm. Let's see which one of you is correct. Okay, so this is 1 by R2 plus 1 by R4. Understood? Till here, understood? So this is simply 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is, ma'am, simply this is 1 ohm. Understood? So this circuit became what now? It became something like this, right? It became something like this. This hole is now R24, which is what? Which is 1 ohm. Right? And this is given, this is 6 ohm and this is 1 ohm. Understood? Now these three are in series, correct? These three resistances are in series, correct? Wait for some time. 8 ohm is divisible by 4 equals to 2. Why? Okay, yes, we'll see. So Rifkat said 8 ohm, not 2 ampere. See the difference. This is where I want you to see the things very clearly. You can be right, just hold on some patience. Okay, now this is the resistance. Now these three are just in series, right? This is R1, this is R3. If you add these three, so the final equivalent resistance will be what? R1 plus R24 plus R3. Correct? Till here everything is correct. Then R equivalent will be R1, that is 1 ohm, plus R24, that is 1 ohm, and R3, that is 6 ohm. Correct? That is 6 ohm. So R equivalent comes out to be 8 ohm. Understood? R equivalent comes out to be 8 ohm. So 8 ohm was the correct answer. That who said? I remember someone said 8 ohm. So that is the answer for equivalent resistance. Correct? Just a second. Yeah. So R equivalent comes out to be 8 ohm. Now we have to find current in the circuit. So this whole circuit becomes what? This becomes 8 ohm, right? This becomes the voltage that is given to us, and this is just a key. Correct? This is 4 volt and this is 8 ohm. Now ma'am, Om Baba ki jai. Right? So Om Baba ने हमें एक फॉर्मूला दिया है भैया, जिसको यूज करके we'll use that, and the formula is V equals to I into R. Correct? This is a very important, very basic, the most important formula for your class 10th for electricity. Okay? So the formula is V equals to IR. V is given as 4 volt. Correct? I we have to find, and R is given as 8 ohm. Understood? R is given as 8 ohm, right? We solved first the parallel, that is 1 ohm, added everything, 8 ohm. Now R is 8 ohm, V is 4 volt. So current comes out to be 4 volt divided by 8 ohm, right? This is 8 ohm. Now current will be 1 by 2 ampere. Units are very important, and 1 by 2 is 0.5 ampere. Understood? 8/4 नो बच्चा, V equals to IR है हमारा फॉर्मूला, ठीक है. When you put V equals to IR, this formula is correct. Let me know, this formula is correct, right? You don't have any problem in this formula. If you put V equals to 4 volt, I and R equals to 8 ohm, and then I goes in the denominator. So this will be 1/2, that is 0.5 ampere. Correct? Yes, correct now. No 2, no 32 or 8 ohm. 8 ohm was correct though. ठीक है, समझ में आई? Understood? Any doubt? Yes, 1/2 is right. Okay? Any doubt? But 2 is also right. How is 2 right, Bunty? 2 कैसे सही है भैया? Okay, let me know 2 कैसे सही है. Okay, let's move on to the next question. Oi, I have, अरे यार, I made this on PPT and I had the answers in the next animation. तो यहाँ पे ऐसे ही आ गया, कोई बात नहीं. List 2 advantages of connecting electrical appliances in parallel with the mains instead of connecting them in series. Right? Pretend that this whole part is not here. Right? We'll solve this first. ठीक है? अरे it's fine, it's fine. No need for sorry. We are all here to make mistakes to learn. Okay? There is no need for anything. ठीक है? तो the question is, this is again a CBSE 2022 question. The question says, list 2 advantages of connecting electrical appliances in parallel with the mains instead of connecting them in series. ठीक है? Yes. So these are the resistances or my appliances. Let's say this is a bulb and this is a freezer. ठीक है? Okay, and यहाँ पे बहुत सारी आइसक्रीम पड़ी है. Okay, and this is the whole circuit. Correct? Now this circuit is what? This circuit is series or parallel? बताओ. And then there is another resistance. Now this is in parallel, of course. Correct? We know this much difference by now, guys. You have to know this much difference by now. Okay? ठीक है? So they are saying, what is the advantage of connecting our resistances or appliances like this, like in parallel, than connecting them in series? ठीक है? We have to see what is the advantage of connecting our appliances like this instead of like this. So the main 2 points is, in our parallel connection, see what happens in parallel. I know in parallel voltage remains the same, right? In parallel voltage remains same, correct? And current divides, right? Current divides, but voltage remains same. Now if the voltage is same, that means each appliance is getting the same voltage and each appliance is continuing with the same power that is required by it, right? That is actually the second point. In parallel connection, each appliance receives the same voltage, correct? Understood? Each appliance receives the same voltage. In series connection, however, the voltage is divided. We know in series current remains the same. In series current remains the same and voltage divides, right? This is the most basic fact. Current remains the same but voltage divides. Correct? So in parallel combination we get same voltage, but in series the voltage is divided among the appliances, which may cause them to operate at lower or incorrect voltage, right? Affecting their performance. Here they are getting same voltage, here they are getting different voltage, which can affect their performance. Okay? And the first main important point is, see, if this resistance broke, right? If this resistance broke, this broke. So this whole circuit breaks. The current stops moving and the whole circuit, the current here stops moving and the whole circuit breaks. But even if this resistance breaks, right? The current is not going from here now, but in this circuit, the current is still there, right? So if my fridge is here and this is my charger, right? If a fridge is here and this is my charger, if the charger socket breaks, the fridge is still getting the voltage, right? So that is very, very important. In parallel connection, each appliance operates independently. Each appliance is operating independently. If one appliance stops working, if this appliance stopped working, the others will continue to function normally. Okay, then in a series connection, if one appliance fails, in a series connection, if one appliance failed, the entire circuit will be broken, causing all the appliances to stop working. Correct? Hello everyone. Hello Mudit. Hello Shubh. If one fuse breaks in series, it will affect the whole circuit, but if it is in parallel, it will not affect the whole circuit. Correct. Charvi, I know if I'm pronouncing it right? Charvi. Correct. What your answer is, the answer is correct. If any appliance is connected in series and it breaks down, the whole circuit will stop getting the current. But if here one appliance breaks down, the other circuit, the other parts will keep getting the current as always. Okay. Hi, next toppers. Okay, let's move on to the next question, that is, okay, now before moving on to the next question, I want you to subscribe this channel. Go ahead, like this session and subscribe this channel. We are coming with a very big live today, right? We are doing this huge mega live today, so I want you to like this session. I'm watching it. Like this session right now and subscribe the channel. Okay, because we are bringing these mega live marathons every day for you. We'll be bringing more as well. Come on, like this session and subscribe the channel. Very good. Yes, next question. Moving on to the next question on our very good student demand. The next question says, an electric motor rated 1100 watt is connected to 220 mains. Whatever is given in the question, read it carefully, write it down. Okay, so an electric motor is rated 1100 watt. Now this is watt. So watt is what? What is the unit of power? Correct. So this is given as, power is given as 1100 watt. Understood? Power is given as 1100 watt in this question. Find the current drawn from the mains. We have to, and it is connected to 220 volt mains. So voltage is also given, potential difference is also given, that is 220 volt. These two things are given to us in the question. Correct? Now the first part, they are saying we need to find the current drawn from the mains. We need to find the current. Now tell me, what is the most important formula that relates power, voltage and current? What is the formula that is a relationship between power, voltage and current? Let me know. What's the formula for power, voltage and current relation? Power equals to what? Okay, power equals to potential difference into current, right? Power, to find current, we have a formula that relates power equals to voltage into current. Understood? Yes, Bunty, that is correct. Power equals to V into I. Correct. Now we are given with power, we are given with voltage. We can easily find I. Just put these values here. 1100 watt equals to voltage is 220 volt, correct? And I is the current, right? So current is equals to 1100 divided by 220. Now can you easily solve this calculation? This is very easy. 22 is, if you divide 110 divided by 22, that gives you 5. So current comes out to be 5 ampere. Correct? Current comes out to be 5 ampere. First question done, right? First part done. Coming to the second part, it says electrical energy consumed if the motor is used for 5 hours daily for 6 days. Correct? So they are asking us that we found the current. Now they are asking us what is the electrical energy consumed if the rate of 1 unit electrical energy consumed if the motor is used for 5 hours daily for 6 days. Now they have asked us to see the electrical energy. What is the formula for electrical energy? Electrical energy is the product of what? Electrical energy is the product of power into time. Correct? Electrical energy is the product of power into time. Hi Muhammad. Right? So electrical, yes, Bunty has said 5 ampere. Sharvi has also said 5 ampere. Very good, very good. Do not forget to put these units with your solutions, okay? Now, electrical energy is, power is given, that is 1100 watt, correct? And time kahan hai? Time is also given 5 hours. See, 5 hours for 6 days. So, time we have to find for a second. Time is 5 hours, but these 5 hours we are consuming for 6 days. So, we'll multiply 5 into 6, right? 5 into 6 is, that means in total he has used that electric motor for 30 hours, right? He has used for 30 hours. Now I can put this 30 hours here, correct? Very good, Bunty. So 30 hours here. So electrical energy comes out to be 3300. And what is the unit of electrical energy? What is the, 33,000, sorry. What is the unit of electrical energy? Electrical energy's unit is kilowatt hour. Correct? Electrical energy's unit is kilowatt hour. So, this is the answer to my first part, right? This is the answer to my second part. Understood? Moving on. The next we have total cost of energy consumed if rate of 1 unit is ₹5. ठीक है? 30 hour convert into second. देखो, for electrical energy the unit is kilowatt hour. So we are using it in the time as hour. So it is given in hours. So we'll use that same time. We will not convert it to seconds. That will make into kilowatt seconds, right? But the commercial unit of electrical energy is kilowatt hour. Understood? Okay. So now we have to see the total cost of energy consumed if the rate of 1 unit is ₹5. Now 1 unit, this 1 unit is in term is 1 kilowatt hour. 1 kilowatt hour is what we call as 1 unit. Okay? Hi Arya, how are you all? ठीक है? So 1 kilowatt hour is actually known as 1 unit. Now they have asked the total cost of energy if rate of 1 unit is ₹5. So how does this go into? Yes. So the rate of 1 unit is cost. The cost of 1 unit is ₹5. Understood? The cost of 1 unit is ₹5. Now we have 33,000 kilowatt hours. 33,000 kilowatt hours, and 1 kilowatt hour is 1 unit. So 33,000 kilowatt hours are in term how many units? 33,000 units. Understood? 33,000 kilowatt hours is 33,000 units. Correct? Then, so 1 unit is ₹5. 33,000 units. 33 33,000 units will be how much? They will be 33,000 into 5. And what will be the answer to that? That will simply be 165K. This is rupees. Okay? 165,000 rupees. Very good. Correct? Can we move on to the next question? If you have any doubt in this whole solution, let me know. This is the whole solution. We found the current first by using the formula, that is P equals to V into I. Then we moved on to find electrical energy, right? Then we found the cost of that electrical energy, that comes out to be 1,65,000. So if you are using an electric motor which is consuming a power of 1100 watt in your home, and you are using it for 5 hours daily, then this much is what you have to pay for a month. That is a lot, right? Let's move on to the next question. Okay, hello Bindu. Hi everyone. How are you all doing? How is your preparation for the board going? Are numericals still scaring you? The physics numericals, you are still scared? Okay. Let's move to the next question. This question says, find the minimum resistance. What we have to do? Find the minimum resistance that can be made using 4 resistors, each of 20 ohm. Very well, Bante is saying. That is good. So, we have to find a resistance. It's boring subject, maths and physics. That hurts my feelings. Physics is not boring, guys. Come on. Okay, we are also doing so many experiments on our channel that will make you feel physics as not boring. Okay, so let's find the minimum resistance that can be made using 4 resistors, each of 20 ohm. So first of all, what do I have? I have these 4 resistors, correct? I have these 4 resistors, each of 20 ohm, 20 ohm, 20 ohm, 20 ohm. Now they are saying how should they be connected so that we get minimum resistance, correct? So they have minimum resistance. Now what are the combinations in which resistances can be connected? There are 2 types. They are either series and are in parallel, right? Now in series we add all the resistors, right? We add all the resistors, but in parallel we take the reciprocal. We take the reciprocal of each resistor and then add those, correct? Right? Now if you look into these, in which case the resistance will be less. If you are adding a resistance, of course the equivalent resistance will be more than the individual resistances. This is very basic. If you have 1 ohm, you add them, they will become 2 ohm, right? They won't become 0.05 ohm or something like that, right? Correct? Now, but in parallel, when you add 1/2 plus 1/2 plus 1/2, all these combine and they get a equivalent resistance which is less than the total resistance, correct? So, in parallel, the equivalent resistance is less than the individual resistances, correct? Now, for that, what do we have to do? Do I have another slide? I don't. So, let me clear this one. Okay, let's see how will we see. So in parallel, if I do in parallel, that will be 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, correct? So that is 1 by 20 plus 1 by 20 plus 1 by 20 plus 1 by 20, correct? Now if you take their LCM, they will come out to be 1 plus 1 plus 1 plus 1, correct? That will be 4 by 20. This is 1 by RP, correct? So RP is what? RP is 20 by 4, which is 5 ohm, correct? RP is 20 by ohm, which is 5 ohm, right? Which is definitely less than the 20 ohm, correct? 1 by 5, yes, but you have to reciprocate it then. Why? Correct? Now, if you add these, if you add RS is, if you add 20 plus 20 plus 20 plus 20, right? That will be what? That is 80 ohm. So R in series is 80 ohm, but the same in parallel is only 5 ohm, right? So definitely in parallel combination we get the minimum resistance, correct? So definitely we'll get the minimum resistance. Can you tell me what's in the physics to attract, to love him? Okay. Physics is a cool subject, guys. If you study it properly, do it with the experiments. We did so many cool experiments in our +1, +2 and in graduation. It is such a lovely subject. Of course, calculation can be a little heavy, but it's a good subject. Okay. So, Rifkat is also saying 5 ohm. 5 ohm? Yes, very good, very good. Great. Okay, let's move on to the next question. Understood? This whole concept is clear. In series, equivalent resistance increases. That is, we can clearly see 80 ohm. In parallel, equivalent resistance decreases. That is, we can clearly see 5 ohm. Correct? Okay. Moving on to the next question, we again have a combination of resistors, right? We have so many. Now the combination of resistors is even more. See, we are increasing our level, right? So the first thing they have asked is effective resistance of the circuit. We have to find effective resistance of our circuit, correct? Understood? So how will we find this? Just a second. So how will we find this effective resistance? See, there are these two series. Let's just name them first. R1, R2, R3, R4 and R5. Correct? Now how will you approach this, right? Any is the fan of King Virat. Oh, I am the fan of King Virat. Okay, so we have 5 resistances. Now what we have to do, we first look in where to look at the first resistances, which circuit is to use first, right? So these two resistors, look at the fourth and fifth resistor. ठीक है, अब in these 4 and 5th resistor, these are in series, so we can add them, right? R4, okay, let's add it here. See, the first thing we'll start with equivalent resistance, right? We'll find equivalent resistance. In that, the first step is we'll see R4, 5. That is R4 plus R5, correct? R4 plus R5 is 4 ohm plus 6 ohm. That is 10 ohm. Understood? That is 10 ohm. Correct? Okay. Then what we are, yes, I know every one of you loves Virat, loves Dhoni. I know. I also love thala for a reason, huh? But we also have boards, okay? So also focus on that, right? So first we studied these two resistances. Now what is the circuit has made? I'll make a short, smaller circuit, okay? Now since we have solved these, instead of these two, I can write just only one resistance in that place. Here, instead of 4 and 6 both, I'll have one resistance, that is 10 ohm. This is again 10 ohm. This is again 10 ohm. And this is 5 ohm. Understood? Yes, ma'am, thala. Yes, thala. Thala is great. थोड़ा कैमरा ब्लर है. नहीं. ठीक है. हाँ, now is fine. Thank you. Okay, so maafi for that, had a little camera issues. Okay, now we have found the resistors and the circuit is this now, correct? Understood? Now what we need to do, this is the same question we did before, right? What we have to solve this now is this part of the circuit. Why? Because you can't add these in series because there is an hindrance. This is an hindrance, right? So we have to solve this into one. We have to merge these two resistances R2 and R45 into one resistance, right? So what we'll do again now, R2, for R2, this is R2, this is R1, this is R3, and this now is R4, 5. Correct? Okay? Understood? This circuit is clear? Correct? Now, R2, 4, 5. These are in parallel. So, we'll use the parallel combination formula. That is 1 by R2 plus 1 by R4, 5. Correct? So, 1 by R2. R2 is what? This is this 10 ohm. So, that is 1 by 10 plus. Now, this R4, 5 is also 10. So, this is also 1 by 10. Right? Now that will, if you take the LCM, that is 1 plus 1, that will be 2 by 10. And hence 1 by R, 2, 4, 5 comes out to be 2 by 10, and hence R2, 4, 5 comes out to be 10 divided by 2, that is 5 ohm. Understood? Correct? So we again merged these two resistances into one, right? Can we make the resistance, this whole circuit again? This is now one resistor. Now those two are merged into one. This is another, and this is the whole circuit. Correct? This was 5 ohm, this was 5 ohm, and this is 10 ohm. Understood? This was 5 ohm, 10 ohm, and these two got merged as they are in parallel. These two got merged and they became 5 ohm. Correct? Oh, चोट हो गई सबके साथ. Okay? ठीक है? So, R equivalent is what? R1 plus R2 plus R3, right? So, 5 plus 5 plus 10, that comes out to be 20 ohm. So R equivalent, the resistance of the whole circuit comes out to be 20 ohm. Hi Sheetal, hello, hello. Correct? So R comes out to be 20 ohm. Understood? Now we just need to see what we had to find. We had to find the effective resistance. So first part is done, right? This first part is done. Effective resistance of this circuit is this is the first part is done. Effective resistance is 20 ohm. Understood? Correct? Everyone clear with this answer? Right? Then what is the second part? They have asked current drawn from the battery. Very simple, very simple. Okay? So what we have to do in the second part? In the second part, they have asked us to find the current. They have asked us to find the current. Now, ma'am, I have a resistance and I have a voltage. Voltage is already given, right? That was 4 volt. So again, Om Baba ki Jai. Okay, my name is Jwal. Is it Jwal? Hi Jwal. ठीक है? So Jwal, बताओ. This is given, right? हमको निकालना है current. Correct? So we have to find the current, and to find the current we are given with voltage and resistance. तो क्या ही दिक्कत है? ठीक है? सीधा V equals to IR. तो voltage is given as 4 volt. Correct? And current we need to find. Resistance is given as 20 ohm. Right? So I is 4 by 20. Correct? I is 1 by 5. ठीक है? 4 5s are 20. Right? 4 5s are 20. Hi Ibad. Hello everyone. How are you all doing? And we have got one answer, that is 0.2 ampere. That is very much correct. So I is 0.2 ampere. That is our final answer for the second part. Correct? That is the answer for the second part. Very good. Now, seeing the third part is potential difference, but across the 5 ohm resistance. This potential difference across the 5 ohm resistance. समझ में आई? Now we have to just find the potential across this 5 ohm resistance. That means, see, now this 5 ohm is in series with the rest of the resistances, right? This is in series with the rest of the resistances, correct? So in here, what will be the voltage going? That we also have to see, right? We have to see the voltage difference is what we have to see. ठीक है? So these are in series, correct? These are in series combination, and in series combination we know that the current does not divides. Current remains same, right? And the current was what? Current came out to be 0.2 ampere. Right? So current is 0.2 ampere and it will be same for the whole circuit because the resistances are in series, and for series current remains the same. ठीक है? Understood? Okay? So current is 0.2 ampere, resistance is, that is given 5 ampere. Again, Om Baba ki Jai, V equals to IR, and I is given as 0.2 and resistance is given as 5 ohm. So voltage या potential difference will come out to be directly, will be 1 ohm. 1 ohm nahi, sorry, 1 volt. Understood? Is this clear now? So this is my answer to the third part. Okay. If someone makes friend with Arya Verma, he or she is very interested. ठीक है? Let's move on to the next question. Everyone understood what exactly we did in this particular question? ठीक है? Hi everyone. What are you guys even writing? Okay, let's move on to the next question. Right? Let's look at the next question. The next question says, let's read it again. very carefully. ठीक है? The question says, hello Shivam Kumar, hi. So write the relationship between electrical resistance and electrical resistivity. What we are asked, see, if you can write, that is very good. If you can, I know in their exam they won't let you write anything on the question paper, right? So what you have to do, you have to mark or highlight the very important things and then write down on your answer sheet. What you have to do, you'll get an answer sheet, right? So write the relationship between. Now the first thing they've asked is electrical resistance. So write down electrical resistance and electrical resistivity. How do you write electrical resistivity? That is the symbol rho, right? So resistance and resistivity, we have to write the relationship between them, correct? For a metallic conductor of cylindrical shape, hence derive the SI unit of electrical resistivity. Hi BG Gaming. Shivam Kumar is saying आज मेरा birthday है. Happy birthday Shivam Kumar. Okay. Ohm/ohm meter. Ohm. First is for what? Okay, so very important formula, we know that is the formula for resistance. The formula for resistance, that resistance formula is what? That is simply R equals to rho L divided by A, right? And here the rho, here this rho is exactly, this rho is my resistivity. ठीक है? Understood? This rho is my resistivity and this R is my resistance. ठीक है? Okay, so R is resistance and rho is resistivity. Thank you मैम. Thank you से काम थोड़ी चलेगा. पार्टी नहीं दोगे? इधर आयो. You have said मैम today is my birthday. So पार्टी कहाँ है? Okay, I wish you a good luck for your 10th boards, right? Hi, good morning everyone. Okay. Let's move on to the question. So this is the resistance and this is the resistivity, and this is our main relationship between resistance and resistivity. Understood? Okay, then they are asking, hence derive the SI unit of electrical resistivity. How will we derive the electrical resistivity? Ma'am कल मिलेगा. Okay, I'll be waiting. ठीक है? So R equals to rho L by A. Whenever they ask you to find the SI units, what you have to do? You first have to write down the formula. ठीक है? Then you write down SI units of every term in that formula. ठीक है? अच्छा, tomorrow is your science paper. All the best for that. What science paper is there? These are pre-boards, right? Of course, but these are pre-boards, right? So for resistance, my SI unit is ohm, correct? We know that. And then resistivity is what we have to find, right? For length, exactly ma'am, for length is, my SI unit is meter. Very simple. Then for area, the SI unit is meter square. Area is length into length, yeah, length into breadth, right? So length into length, that is meter into meter. Meter into meter is meter square. समझ आया? Correct? So this 1 meter gets cancelled with this meter, right? So if we cross multiply this, that will be, if we cross multiply this with ohm, this will be ohm meter, that is resistivity. Correct? That is resistivity. Understood? And this, my friend, is the solution to this whole question. Understood? Clear? Ma'am, can you explain one more time? Okay, just give me 1 second. See, they have asked you a relationship between electrical resistance. Now what is electrical resistance? Electrical resistance is denoted by R, right? And resistivity, electrical resistivity, that is denoted by rho. Now the one relationship, what is the formula of resistance? A very basic formula for resistance is simply R equals to rho into length divided by area, right? R equals to rho L by A, right? So rho here is, this rho is resistivity, and this resistance, this R is resistance, and hence this formula will give us the relationship between the resistance and resistivity. Okay, that is the first part. Now they have asked us the SI unit of electrical resistivity. So for resistance, the unit of resistance we know that is ohm. We know very clearly that the unit of resistance is ohm, right? Then to find resistivity, we'll take help of this formula. So you write the formula first, ठीक है? ये formula पहले लिख लिया. Then you substitute the SI units of everything you know. ठीक है? So R is ohm, rho, then L, for L SI unit is meter, and for area SI unit is meter but square, right? SI unit is meter but meter square, not just meter. ठीक है? And then you cancel 1 meter here and you cross multiply it with ohm, you get ohm meter, and that is the unit of resistivity. Understood? Okay? Everyone? Yes, ohm meter. Correct, Sheetal. ठीक है? Let's move on to the next question. That is, now next question says, again a CBSE 2024 question. Step marking होती है क्या? I guess when you do the numericals, in case of numericals, see, if you have not written SI units, ठीक है, तो they will cut half marks, I guess. Yeah, they will cut half marks for you if you have not written the SI units. But if you have not solved the question, you have just written the formula, you will get some marks. You will do the calculation. So in steps we'll go. Sorry. Okay, the camera got. 1 second, guys. Just 1 minute. Yeah. हेलो, एक बार आकाश को भेजना.
ठीक है.
Is the camera fine now? So sorry for that. Let me just check. 1 second. Yeah, it is fine, I guess, a little bit. Okay, let's just start and we'll see. Okay, ठीक है. So the next question, it comes. Is the voice clear? Okay, so the next question that comes is what? It says a battery of 6 volt is connected with a series combination of 5 resistors of 0.1 ohm, 0.2 ohm, 0.3 ohm, 0.4 ohm and 0.5 ohm. ठीक है? How much current would flow through just the 0.5 ohm resistor? So let's make this diagram first. ठीक है? They are saying 5 resistors connected in series. ठीक है? With a series combination. So we have 5 resistors, 1, 2, 3, 4 and 5. ठीक है? We have 5 resistors. This one is 0.1 ohm, this one is 0.2 ohm, 0.3 ohm, 0.4 ohm and 0.5 ohm. How much current would flow? So what did I tell you? Whenever there is a combination of resistances, first you find equivalent resistance. Now in series Ma'am, can I ask one question? Yes, of course you can ask one question. Okay, PG Gaming is saying yes beta. Okay beta. Who are you saying beta to? Sarma ji. Okay, ask the question Sarma ji. ठीक है, so this will be simply R1 plus R2 plus R3 plus R4 plus R5. ठीक है, so that will be 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5. ठीक है, if you add all this 0.1 plus 0.2 0.3, then 0.3 plus 0.3 0.6, 0.6 plus 0.4 that is 1. ठीक है, and 1 plus 0.5 that is 1.5. you can do this much addition. Okay, I trust you this much. Okay, ठीक है, तो R equivalent came out to be 1.5 ohm. ठीक है, now we have to find current through just 0.3 ohm resistor. Now see, this is where you have to use your brains. ठीक है, whenever a current is flowing in a series circuit, it is flowing in a series circuit, what will happen? Current remains same in from every resistance. Current remains same. ठीक है, current will remain same for each of the resistance. That means I will use the total resistance in my ohms formula. ठीक है, we will use total resistance, this equivalent resistance in my ohms formula. So ohms law is V equals to IR. V is given to us as 6 volt, right? So this is 6 volt equals to I we have to find, and R is 1.5. ठीक है, and from here I will be 6 volt divided by 0.5, correct? 1.5. Sorry for that. We have 6 divided by 1.5, and if you just take out this decimal, 15 by 60, now 15/4 is equal to 60. That means I will be 4 ampere. Correct? Whoever said 4 ampere was correct. Hi, hello Prashant. What was, ma'am, if we change voltage of a circuit, will it affect the resistance? Of course. See, there are multiple things you have to consider. This is not just a statement that you can give, right? If there is a resistance in the formula that is given as 0.3, so if you change the voltage, current will change, right? If there is a 6 volt voltage, right? See, say there is no space. This is a resistance and this is 6 ohm, right? And this is 6 volt. ठीक है? Now if you change this 6 volt, this is same. The resistance is same. This is 6 ohm. But if you change this voltage to 8 volt, right? If you change this voltage to 8 volt, so definitely resistance is not changing. What is changing? Current in the circuit is changing. ठीक है? Hi, hello everyone. Hello. Shining star. Hi, shining star. I hope you are shining brightly. Okay? Can we move on to the next question? Novel Preet. Hi, Novel Preet. ठीक है? Oh, this is the next question. ठीक है? Let's look into this question. Read it carefully. ठीक है? Read it very carefully. An electric kettle, there is an electric kettle rated at 230 volt and 1000 watt. ठीक है? Rated at 230 volt and 1000 watt. Calculate the resistance. So what is given? What is given to us in the question? We will write that first. We are given that voltage is 230 volt. ठीक है? And 1000 watt. Watt means power. So power is given as 1000 watt. ठीक है? Understood? Then ओके क्या बातें कर रहे हो, गुज्जर आगे के लिए क्या, ठीक है. So we have to find the resistance of its heating element when it is in operation. So we have to find, see, write it down, we have to find the resistance of its heating element. We have to find the resistance. Now can you all tell me the formula in which is a relationship between resistance, voltage and power? Can you tell me one formula which is a relationship between resistance, power and voltage? Hi Jelina. गुज्जर आ गए मैम क्लास लेने के लिए. हेलो. साइंस बायो का PYQs जल्दी होगा. Will very soon we are bringing all the PYQs. Okay, all the subjects. क्या मैम आप ट्यूशन दोगे? I am teaching you for free here. You have YouTube for free. Why you want tuitions from me? Okay. ठीक है. Let's see. Yes. Sharma ji is saying. Sharma ji का बेटा. P equals to V square by R. That is very very correct. Right. So we'll use the formula. Let's see the solution. Solution is, तो शर्मा जी ने बोला है कि P equals to V square divided by R. ठीक है. Now P is given, this is given, right? This is 1000 watt. Correct? This is given. And V is also given. That is 230 into 230. Can I write? ठीक है. And divide by R. R is what we have to find. Correct? R is something we have to find. Correct? Understood? Everyone? ठीक है. Let me know the answer. What is the answer for this? So have you also studied like the square roots till 30? So when I was in school, I had a math teacher. She was like very good. She made us like cram all the squares till 30 at least. ठीक है. So it is good for you if you can also learn the squares till 30. Till 30 just for some time. You can revise till 20. It is very easy. Some of the things are very easy. So 23. So if you don't remember all the things, you can simply do it like this obviously. So that will be 529. So for R we have 230 into 230 divided by 1000. Correct? And this zeros cancel out. So we have 529 divided by 10, which is 52.9. So the resistance, calculate the resistance. The resistance comes out to be R equals to 52.9 ohm. Understood? Any doubt till here? Right? All this calculation very easy, and it will be very easy for you if you can remember all the squares till 30. ठीक है? Correct? Fine? ठीक है, समझ आ गई? Yes, 52.9, yeah, around. That is same. You will get the marks for 53.1 as well. Because you are doing the calculation by yourself, so it will be fine. ठीक है? Okay. Let's move on to the next question. Next question says, अरे यार, again I did this in PowerPoint, so I had this particular thing in animation, so it will come in the next slide. But here I think some glitch happened. ठीक है? Okay. और मेरा कैसा 53.1 आया? That is something you have to find, bro. ठीक है? चलें आगे. ठीक है. Let's see the next part, which is in an electric circuit, 3 bulbs of 100 watt each are connected in series to a source. Bye BG Gaming. In an electric circuit, 3 bulbs of 100 watt each are connected in series to a source. In another circuit, set of 3 bulbs of the same wattage are connected in parallel to the same source. ठीक है? So we have 3 bulbs, right? We have 3 bulbs. First they are connected in series. ठीक है? First they are connected in series. Then 3 bulbs of 100 watt. ठीक है? So each bulb is of 100 watt. कितना ठीक है करती हूँ मैं. Okay. ठीक है? They are connected in series to a source. In another circuit, set of 3 bulbs of the same wattage are connected in parallel. ठीक है? हरे भगवान, अब तो मेरे को ठीक है ही सुन रहा है. Okay, so this is the bulb, then this is another bulb, and this is another bulb which are connected in parallel to a source. Source is what? Source is our battery. Okay? Understood? Now, what is the exact question? Will the bulb in 2 circuits glow with the same brightness? Justify your answer. So they're asking, will the brightness in which case will be more, or will it be same in both cases? This is in series, this is in parallel, this is also 100 watt, right? This is also 100 watt and 100 watt. Correct? Understood? Then what they are asking is कि in which case the bulbs will glow with more brightness, or will they glow with same brightness in both cases? See, how to approach this question? It's very easy. So the bulb, we have a formula that is V square divided by R. Correct? Now see, in this case, in parallel case, the voltage is same, right? The voltage is same. This is my, let's say 6, 7, whatever volt, or in our houses it is 220 volt. So let's say I assumed, just assumed, ठीक है? Assume from that is 220 volt, ठीक है? So same voltage will go in all these bulbs. Same voltage will go, that is 220 volt will go in all the bulbs. Now formula of power is what? That is V square by R. So each bulb is having same voltage. Very important point. What? Each bulb in parallel is getting same voltage, right? So they will glow with highest brightness. They will glow with highest brightness, right? They will glow with highest brightness. But in case of series, the voltage divides, right? Voltage divides. Voltage is not same. ठीक है? So each of the bulb is getting different voltage. Different means a voltage less than 220 volt. Definitely, ठीक है? This bulb is getting a different voltage. This bulb is getting a different voltage. This bulb is getting a different voltage. Correct? So since all the bulbs are getting a voltage lesser than 220 volt, that means they won't glow with, they will not glow with highest brightness or maximum brightness. ठीक है? अरे, they won't glow with maximum brightness. Understood? So what did we decipher from this? That if the bulbs are connected in series, they will glow with a little lesser brightness than if they are connected in parallel. ठीक है? Okay, understood? बिहार से हैं. Hello बिहार से. Hi from Hi to Bihar. Okay, then what is there any other question they have asked? Yes, so the first part is done. ठीक है, everyone understood? Second, now let one bulb in both the circuit gets fused. See, this is very carefully. I know you guys are busy talking, but see this very carefully. ठीक है? So they are asking, now let one bulb in both the circuit get fused. Will the rest of the bulb continue to glow in each circuit? Give reason for your answer. So they are asking that these are in series. Let's say this bulb got short circuited. This particular bulb, it got short circuited and the current stopped flowing from this, and in this case let's say this bulb stopped working. In both the cases one bulb stopped working. So what will happen? ठीक है, so what will happen in series? We know that in series if circuit breaks, the whole circuit stops working because the current stops flowing from that circuit altogether. But in parallel all the bulbs will continue working. Yes. मैम इस चैप्टर का वेटेज कितना है? इस चैप्टर का वेटेज बहुत हाई है. इलेक्ट्रिसिटी इज अ चैप्टर विच will mostly give you numericals. That's why we are solving lots of them. They will also ask you some conceptual questions that we will also do. So make sure you cover this chapter very, very carefully because it has a very high weightage in your physics syllabus. Okay. So what we are saying in series, let me write here. Yes, in series what will happen if one bulb stops working? ठीक है? If one bulb will stops working, then the whole circuit breaks down. Whole circuit breaks down. Understood? The whole circuit will break down and no current will flow through that circuit. Okay? Then in parallel, on the other hand, in parallel what will happen if one bulb stopped working? If one bulb stopped working, the whole circuit will not break. See, this bulb stops working, right? This bulb stops working, but the voltages, these connections are still intact. These two connections are still intact. That means voltage and current will continue flowing through them. Okay, they will continue flowing through them, and in parallel the circuit won't break down. Appliances or the current will flow independently, or appliances will function independently, not independently, simultaneously. Okay, simultaneously and independently, you can write both. Correct? Understood the second part? आईपीएल की बातें चल रही हैं. यस, बहुत अलग अलग तरीके से क्वेश्चन पूछना है इस चैप्टर से. दैट्स व्हाई वी आर गोइंग टू स्टडी. आई हैव ब्रॉट यू सो मेनी क्वेश्चंस. इट्स अराउंड 25-30 क्वेश्चंस फ्रॉम वन चैप्टर. सो वी विल सी ऑल द क्वेश्चंस फ्रॉम. See, we have seen so many numericals in this live as well, and I've brought you some conceptual questions, a lot of conceptual questions as well. See, something like this, so that it makes you clear all your concepts from the very basic. ठीक है? We are starting from Ohm's law, फिर we moved to electrical energy, we moved to electrical power, we covered everything, right? So you don't need to worry, just practice these questions. These are PYQs, so this is not something I made up. Right? The board has done these kind of questions. Hi, learn with Sudarshan. अरे फिर आ गए फ्री फायर वाले. एनी फ्री फायर कौन खेलता है? ठीक है, let's see this question, very conceptually rich question. Okay, how is electric current related to the potential difference across the terminals of a conductor? See, this does not do justice to my statement, that very conceptually rich question. But if you made a mistake in this question, that is really bad, that I will feel bad. How is electric current? So first is given as electric current related to potential difference. Potential difference is what? V across the terminals of a conductor. So this is very easy. Okay? So V equals to IR. This is the very basic relationship between potential difference and current, right? And this is my Ohm's law. Correct? I am back after 1 month, ma'am. Okay, hello. Let me just read it. What is happening? Free Fire. Okay. A lot of students from Bihar I am seeing. How is the weather there? Ma'am, why area is not changed when length is doubled in cylindrical conductor? Area is changed. See, I'll tell you, you have to see the question. We'll see, I have brought you a question like this. If they are saying that they stretched it, if they stretched the conductor, then area is changing. Okay? Albadi, hello. The area will change when they say that we stretched the conductor or we stretched the wire. So area is changing. Okay? But if they have mentioned that length increases but area of cross section remains the same, then only area will not change. For cylindrical conductor, if length is doubled, area will get half. Okay? Okay, let's see the second point. Oh, okay. Everyone, I know you are trying to have a healthy communication in here, but focus on this point. This is very important. Why should emitter have low resistance? Why should emitter has low resistance? इसका low resistance है, क्यों है? ठीक है? So why emitter has low resistance? It is a very good question. ठीक है? So what happens is, see, emitter, how you have to frame the story. See, even if you know the answer correctly, even if you don't, this is a very खुफिया trick. ठीक है? Even if you know the answer, even if you don't, we should not change percentage conductor. I'll get back to you. I'll get back to you, Sudarshan. I have one question like this. We'll follow that. Okay? Just wait for a minute. Now, here, what you have to make a story. Okay? So now, what is happening? Emitter, we all know, is always connected in series. It's always connected in series in the circuit. Right? So first point is done. The emitter is always connected in series. Now we know in series current does not split, right? It does not change. Now current goes through, see, this is my, let's say this is my one circuit, right? TT. So this is my circuit. What is happening? Current is moving inside it, right? Current is going into the ampere. It is measuring how much current is there. Then the same current is going through these resistances, right? So when current goes through a resistance, resistance does what? Resistance do what? Resistance do what? Resistance cause a hindrance to the flow of current. ठीक है? Resistance causes the hindrance. Resistance causes the hindrance to the flow of current. Flow of current. See, resistance now causes a hindrance to the flow of current. Now, if ampere, this emitter, if emitter has so much resistance, what will it do? It causes a hindrance to the flow of current. And say 5 ampere is going and there is a big resistance. Then that 5 ampere, the value of that 5 ampere will appear to be decreased. right? It will decrease because there it is getting a resistance from the ammeter. So that is why if the resistance of ammeter is high, the value of current that is actually flowing in the circuit, it will get reduced. That current will get some hindrance from the ammeter as well. But ammeter is there to measure how much current is there. So how will it do it? So ammeter should have low resistance so that all the current passes through the ammeter. Okay, let's write it. So ammeter has low resistance so that the whole current can easily pass through it without causing any fluctuation or difference. You can write any difference or any hindrance to the flow of current. Understood? Flow of current. Understood properly? Let me just read. What are you guys saying? Ma'am, बिहार में नहीं रहती, यूपी में रहती हूँ. Oh, Varanasi. I'm planning to come to Varanasi. It is on my bucket list. I'll contact you when I come there. Mom, I'm from Tamil Nadu. Oh, I have been to Kanyakumari. So Tamil Nadu is also on my checklist. I want to do Pondicherry and all. अरे भाई बिहार में तो यूपी है, हाँ? अरे तो अभी okay. ठीक है, let's move on to the next. But in parallel connection, voltmeter can also have fluctuations. What does that mean? In parallel connection, voltmeter can have fluctuations, but voltmeter is connected also in parallel, right? It is connected in parallel with the circuit. So resistance of voltmeter is not low. Resistance of ammeter is particularly low, so that the whole current can pass through it. अब कहाँ डाउट नहीं देखे? कृष्णा शर्मा, ऐसे कौन धमकाता है भाई? डिलीट भी कर दिया. कहाँ है? आई डोंट सी एनी डाउट्स ऑफ योर्स. Okay. Let me know if you have any doubt. I'll definitely get back to you. ठीक है? Okay. Now what is left? See. So understood the whole ammeter part. Why shouldn't? So first part is done. Second part is done. Two VI graphs A and B. Oh, we have A and B. They are A and B for series and parallel combinations of two resistors as shown. State which graph shows a series and parallel combination. See, this is a very important. Hello, Prashant. मैम मजा नहीं आ रहा है तो क्या करूं भाई? मजा लाने के लिए नाचूं? हैं? ओके, वो नहीं होगा मेरे से. Now see the third question. Two VI graphs A and B. हमारे पास दो VI graphs हैं. See, this is V and we have I on x-axis. This is A, this is B. We have to see which graph, either A or B, which of these graphs shows series connection or parallel combination of two resistors. ठीक है? Which one of these two graphs shows series or parallel combination of resistances? See, we have two graphs. Okay, I have some tools to use. Yep. So we have these two graphs. ठीक है? So if you use, if you see carefully these two graphs, see one thing you have to carefully see in this graph is what is written on x and y axis. Here it is voltage, right? On y axis it is voltage and on x axis it is current. This is the only thing you have to see. Rest you can easily do it. There is no need to panic. Rest is, we can easily do it. We can easily do the rest part. Okay? So the first thing you have to do is to check what is there on x and y axis. Now to calculate the slope, what is the slope of this whole graph? The slope will be simply, the slope will be what? Slope will be y-axis divided by x-axis. Okay? In simple, you have studied in math, right? Slope is y-axis divided by x-axis. On y-axis, we have V, correct? On x-axis, we have current. Understood? इतना समझ आ गया? On y-axis, we have V. On x-axis, we have I. After hearing this question several times and my blood is coming. Okay, it's fine, but you need to practice. That's how it gets engraved in your mind and brain and body. Okay? Now this is the slope. But one thing you need to see very carefully, does it matches with what we need? What we need? We need Ohm's law. Okay? We need to find resistance. From where will we find resistance? We find resistance from Ohm's law. See, Sudarshan said it. Even though this question is same, in the exam they can mold it. So your concepts about this question should be clear, right? Everything else we can manage. Okay? So do not forget this question if you just are thinking that you know it. Hey, why this is off? Just a minute. Okay? So what is, from here we have V equals to IR, right? And from here R equals to V divided by I. Correct? Is it V by I here? ठीक है? So we can write V by I as R. अरे क्या हो गया? क्या हो गया? मैम क्यों लिख रहे हैं? Okay, wait for a second. Then, so this is the exact thing we needed. Now since we have it, see, this is the exact thing we needed, correct? R equals to V by I. So this is the correct formula. It matches with our Ohm's law. That means the more the slope of this, graph, the more will be the resistance. This is slope of A, this is slope of B. Okay? So slope of A is definitely greater than slope of B. Correct? That means R, slope is my R, right? Then R of A, that is resistance of A, is greater than resistance of B. Understood? Resistance of A is greater than resistance of B. Now what was A and what was B? If resistance is more of a combination, that means that combination is a series combination. Coming back to you, I've seen your question, just a minute. If resistance of a combination is more, that means that combination is what? That combination is a series. So A is series combination and B is parallel combination. Understood? A is series combination and B is parallel combination. Okay? बोले मैम आप भोजपुरी सॉन्ग सुनती हूँ मतलब ऐसे बहुत ज़्यादा नहीं, पर कभी कभी तो सुन ही लिया होगा. Then why should we keep a resistance as constant in the slope of a graph? Why there is need? When did we keep resistance constant? See, there is a circuit. You have a resistance in the circuit. So in that, resistance is already constant. Now you are changing the voltage. Because of that change in voltage, current is changing. That is correct. That is what this graph is about. This is the variation of voltage with current for a particular combination of resistance. ठीक है, as the voltage is increasing, resistance is same. 5 ohm resistance is there in a circuit. As the voltage is increasing, current is increasing. That's why the resistance, you can say that the resistance is constant. Okay, now resistance of A is definitely different than resistance of B. This you need to make sure. Okay, क्लास कब तक चलेगी? क्लास तो बहुत देर तक चलेगी. We are doing a mega live today. All the questions of all the chapters we are going to do today. Okay. Okay. Next question. We are done with all the parts, right? Let's see the next question. That is, now ma'am will be forming the formula, we are keeping constant, like that they said in my school. Now while they deriving the Ohm's law, here we should keep us RS constant with a constant temperature. Yes, that is the definition of Ohm's law. Definitely you are right. When there is a conductor, right, there is a cylindrical conductor or whatever conductor we have, in that we are passing a current and there is voltage difference across the ends of the conductor. So definitely because of the ions, atoms of that conductor, a resistance will be there to the flow of charges and hence current will be low. Correct? Understood till here? So that is why for that particular conductor resistance is same. Or if I am taking a particular this circuit, right, I've told you this is, let's say, 6 ohm and this is 6 volt. So we have voltmeters and we have different kind of devices through which we can increase or decrease the voltage, right? So we have different voltage sources. We can increase the voltage but resistance is same. Resistance is constant. So I is increasing. And to verify Ohm's law, so that Ohm's law work, Ohm's law is what? Voltage varies linearly with current. As the voltage increases, current increases. That means for that to happen, the temperature, pressure of our surrounding has to be same. ठीक है? समझ में आई? समझ में आ गया? क्या कर रहे हो यार लाइव चैट में? मुझे धमकियां दे रहे हो? ठीक है, छोड़ो. चलो. Next question, it says 4 wires of equal length and resistance 10 ohms. अरे यार, 4 wires, read this question carefully. 4 wires of equal length and resistance of 10 ohms forming a square. अच्छा, शिवम कुमार को धमकी दे रहे हो, बहुत अच्छा. चलो देखो, 4 wires of equal length and of resistance 10 ohms forming a square. So we have 4 wires and their resistance is how much? Their resistance is 10 ohm. Understood? This is given. They formed a square. Now they formed a square. Let's say these are the 4 wires and they formed a square. ठीक है? The equivalent resistance between two opposite end of the squares. Now this and this is the two opposite ends of a square. Correct? Then this, if I connect this with the voltage, these two ends, if I connect this with the voltage, then it becomes a proper circuit, right? They just asked us that its resistance is 10 ohm, its resistance is 10 ohm, 10 ohm, 10 ohm. Just tell me what is the resistance between these two opposite ends, A and B. What is the resistance between, so let's say R1, this is R2. Whenever you get a question like this, you just name all the resistances that are there in the circuit. ठीक है? समझ में आया? Then let's add, see now, if I make this circuit again, this is something like this. ठीक है? 10, 10, 10, 10. Now you have to find the resistance between these two ends. That is A and B. Correct? So for A and B, these two are in series. So I'll just add R1 plus R2. That will be 10 plus 10. That will be 20 ohm. Correct? Then this is R3. This is R4. These two are also in series. So this will be R3 plus R4. That will be 10 plus 10. That will be 20 ohm. Understood? Now these two, let us name them RA and RB. Now these two are in parallel. What exactly our circuit becomes now? Our circuit became something like this. It became something like this. 20 ohm, 20 ohm. Correct? So we have 20 ohm and 20 ohm. Understood? समझ में आई? Now what we have to do? See, these are 20 ohms. This is my 20 ohm and this is my 20 ohm. We can clearly see they are in parallel. So that is 1 by 20 plus 1 by 20. That will be 2 by 20 and that will be 1 by 10. That will be 0.1 ohm. So the total resistance of this whole circuit is what? 0.1 ohm. Understood? Sorry ma'am, 10 ohm. Arey, sorry. Yes. Correct. You are correct. I am so sorry for this. This is 1 by R parallel. So R parallel will be 10 ohm. Correct? This is your final answer. Understood? Answer 10 ohm. Yes. Answer is 10 ohm. Correct? Let's move on to the next question. Next question says, a battery of 10 volt carries 20,000 coulomb of charge. A battery of 10 volt. Battery of 10 volt carries a 20,000 coulomb of charge. So charge is 20,000 coulomb. ठीक है? Through a resistance of 20 ohm. The resistance is also given. सारा कुछ तो दे दिया. What do we have to find? The work done in 30 seconds. We have to find the work done given that the time is also 30 seconds. Understood? Clear? ठीक है? तो हमको find करना है work done. अरे when you have to find work done, all you have to know is the basic formula of potential difference. What is potential difference? Ma'am, potential difference is the work done to bring a charge from one point to another, per unit. Now that charge is 1 coulomb. Bring a test charge, you can say. So that is per coulomb. So potential difference is work done per unit charge. That means we have to find work done. Work done is V into Q. V is given, that is 10 volt. Q is also given, that is 20,000 coulomb. Both are in SI units. So these are 20,000. That is 2 into 10 raised to power 5. Unit is joule. Unit will be joule. Understood? Till here everything is clear. Correct? Done with this question? B. Oh, I have answers. Correct. Everyone is correct. The right answer is answer number B. That is great. Halla bol. Oh, we have a cat in our class. ठीक है. Let's go to the next question. 4 identical resistors, each of resistance 8 ohm, are first connected in series and with resulting resistance as Rs. Then they are connected in parallel with the resulting resistance as Rp. ठीक है? So first the 8 ohms resistance, we have 4 resistances. First they are connected in series. ठीक है? And then they are connected in parallel. That is a bad drawing. These are then connected in parallel. Okay, till here everything is clear, and each resistance is of 10 ohm. ठीक है, then connected in parallel with resulting resistance as Rp. Where did this go? I made it, I remember. Okay, find the ratio of Rs by Rp. They are saying what is the resistance in this case and what is the resistance in this case, and then we have to find the ratio. Correct? Very good. So this is simply R1 plus R2 plus R3 plus R4. That is R1 plus R2 plus R3 plus R4. Understood? All the resistances are of 8 ohm. That means 8 plus 8 plus 8 plus 8. That means what? 4 into 8. Now, if you want to use some brains, you can easily write, as the resistance is same for all, you can easily write N into R, where N is number of resistances, that is 4. R is the one resistance, that is 8. Right? So this will be 4 into 8, and it will be in both cases 32 ohm. Understood? Rs is 32 ohm. आ गया? यहाँ तक clear है? Then Rp for parallel, ma'am, we know the formula is different. Simply 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Again, if you want to use your brain, this is for same resistances, the formula becomes N by R. Okay, then all will be 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, or this is 4 by 8. If you take the LCM, you will get 1 plus 1 plus 1 plus 1, which is equal to 4 by 8, right? So Rp comes out to be 1 by 2, or this is 1 by Rp. Hey, I do this mistake a lot. So Rp comes out to be 2 ohm. Remember this, don't do this mistake in your boards. This is 1 by Rp, not Rp. Correct? So now we have to find the ratio of Rs divided by Rp. The ratio of Rs divided by Rp. Rs divided by Rp. बोलो, correct? समझ में आया? Give me a thumbs up if all these questions are clear to you, right? So Rs divided by Rp. Rs is what? Rs comes to be 32 ohm. Rp is 2 ohm. Rs is 32 ohm. Rp is 2 ohm. So this will be 16 ohm. So the ratio of Rs divided by Rp is 16 ohm. Understood? And we have the answer as option number C. अरे यार, option number C. Very good. Everyone, very, very good. ठीक है? Let's move on to the next question. Next question says, oh, we are on to transitioning to the next chapter. I am thinking. Let's follow this. Let's see these questions very carefully. Okay? Now, draw the pattern of the magnetic field lines for the two parallel straight conductors carrying current of same magnitude I in opposite directions. Now, you are given two parallel straight conductors. They are carrying current, right? They are carrying current of same magnitude I, but the current is in opposite direction. The current is in opposite direction, right? Show the direction of magnetic field at a point O, which is equidistant from these two conductors, right? Which is equidistant from these two conductors. समझ में आई? So what we have to do, we have to find the direction of magnetic field. See, there are two rules that we are studying in this chapter. The first rule is right hand thumb rule, right? First is right hand thumb rule, right? The second one is Fleming's left hand rule. Second one is Fleming's left hand rule, right? So we are using both the hands for one rule each. Okay? Now for right hand thumb rule is used to calculate, is used to find the direction of what? Okay? It is used to find the direction of magnetic field. It is used to find the direction of magnetic field. Correct? It is used to find the direction of magnetic field. On the other hand, what is Fleming left hand rule is used for? See, from F, Fleming left hand rule is used to find the force on a current carrying conductor. Force on a current carrying conductor placed in a or moving in a magnetic field. Correct? So these are the two basic concepts of our chapter. Now here we have to find the direction of magnetic field. That means magnetic field. That means we will be using right hand thumb rule. Understood? Doubt है? हाँ बताओ ना क्या doubt है? Ask. किसको हेलो बोलना है? ओके, यू डिसाइड क्या डाउट है, किसको हेलो बोलना, देन टेल मी. अंटिल देन वी आर सॉल्विंग दिस क्वेश्चन. ठीक है? So we are using right hand thumb rule. Now what is right hand thumb rule? You point your thumb in the direction of current. You point your thumb in the direction of current and you curl your fingers. You curl your fingers around that current, and the direction of curling of fingers will give you the direction of magnetic field. Let's see how it works. See, here the current is going in upward direction, correct? And we curl our fingers something like this. Okay? The current is going in upward direction and the curling of the fingers will give the direction of magnetic field. That means the direction of magnetic field will be going in, will be circular first, will be circular, and they will be going inside here. They will be going inside from this side of the wire, and they are coming out from between the wires. This one understood? क्या बोल रहे हो शिवम ब्रो? मैम को बोलो ना हम क्या बोल रहे हैं, क्या बोल रहे हैं. सारे क्वेश्चंस में डाउट है. ओके ठीक है. अभी देखो, राइट हैंड थंब रूल एंड इट गोज इन, करेक्ट? देन वी यूज द सेम राइट हैंड on this wire, but now the direction of current is reversed. ठीक है? So the direction of current is downwards now. Now if I curl my fingers, so they will go inside at this point. They will go again, they will be in concentric circles. They will be going in from this point and then coming out from inside, right? समझ आया? Then what will we see? Inside these, between these wires, the magnetic field due to both of the wires, it is coming out. It is coming out. That means first point, it is not getting cancelled, right? First point, it is not getting cancelled. So at the point O, both the magnetic fields are coming out. So the magnitude of magnetic field at O will be doubled. Simply you can write this. Okay? We have to show the direction at this, so it will be coming out. For coming out we use a dot or a dot. Okay? Understood? Okay, moving on to the next question. We have a wire of length L. See, this is the question somebody was asking. A wire of length L is gradually stretched so that its length increases to 3L. So we have two Instagrams. I just read. Hey Bhagwan, you guys are very bad. Instagram की बातें कर रहे हैं. I just said Instagram. ठीक है. So we have two cases. In the first one, L1, the length was L, right? It is stretched. See, the keyword here is stretched. Understood? The keyword here is stretched. So L2 now is 3L. Understood? If its original resistance is R, if R1 is R, then its new resistance will be. We have to find the new resistance. ठीक है? Understood? We have to find two resistances. समझ आया? Now, since the word stretched is here, that means when I'm stretching something, its length will increase, but it will get patla, right? It will get patla. That means its area of cross section will decrease. Understood? The area of cross section will decrease. ठीक है? So, area of cross section in the first case was A, but it will decrease by the same amount the length is increasing. So A2 will be, this is length is increased by 3L. So area will decrease by 3. Area will decrease by 3. So that will be A divided by 3. अरे यार तुमको नहीं पढ़ना, यही सब करना है तो चले जाओ. पढ़ ली मैंने उसकी बहुत बड़ी बात. मैम आशीष भाई कुछ बोल रहा है. If you don't want to study, you can leave the class. Nobody has bound you here. Why are you disturbing other people? And whatever. Okay. So now then the new resistance. We have to find R2. Okay. We have to find. Okay. So first look at this case. ठीक है? So R1 is, the formula for resistance is rho L1 divided by A1. Correct? R is rho L1 divided by A1. Okay. Now R2 will be rho L2 divided by A2. Correct. Now L1 here is simply L. So can I write R1 will be rho L by A? Right? R1 is rho L by A. So here now L2 is what? It is 3L, not just L, 3L. This is rho into 3L divided by, now A is A by 3. ठीक है? A is A by 3. That means it will be 3 into 3, 9 into rho L by A. यहाँ तक समझ में आया? Understood everyone? Okay. So R2 is 9 rho L by A. Now this rho L by A is equal to R1, right? So this is 9 into R1 and R1 is also given as R, that is 9R. Correct? So R2 is 9R. That is our final answer, my friend. ठीक है? R2 is 9R. Understood? Everyone understood? Okay, let's moving on to the next question that says, oh, we have an assertion reason question. Give me the answer to this question. Read it carefully and give me the answer to this question. What is the answer to this question? Assertion reason question. Okay. How will you solve this question? How will you go about this question? So assertion reason questions, just read what they are saying first and then I'll tell you how to solve this. ठीक है? assertion is saying that resistance of a copper wire of length 1 meter and area of cross section 1 meter square. That means there is a copper wire and they are saying its length is 1 meter and area is 1 meter square. This is meter square. ठीक है? Is the same as the resistance of an aluminium wire. Then there is another aluminium wire. Its resistance of a copper wire of length this and area this is same as the resistance of aluminium wire of length again 1 meter and area of cross section 1 meter square. So they are saying that resistance of copper is equal to resistance of aluminium and both have same dimensions as well. Okay. We'll see, is that true or not? Then reason is resistance of a metallic conductor depends on the nature of the material of the conductor. Here the main point comes. Okay, we got an answer D. Okay, so they are saying that even though copper and aluminium are different materials, but since they have same dimensions, right, and they have same resistance, they are saying that they have same dimensions, so they will have same resistance. See, what is the formula of resistance? It is rho L by A. So L is same, A is same, but rho to different hai na. Rho is what? Rho is resistivity. Rho is resistivity, and we know, ma'am, don't trick us. Resistivity is same, is different, resistivity is different for different materials, right? It is different for different materials. That means even if length and area is same, resistivity of aluminium and copper will be different because it's the property of a matter. ठीक है, resistance is a property of that single matter, that single material. So resistivity of copper will not be equal to resistivity of resistivity of aluminium, and hence resistance of copper will not be equal to resistance of aluminium. Understood this part? Understood this part very clearly? So the assertion is definitely false. Reason, on the other hand, does say that resistance of a metallic conductor depends on the nature of the material. So resistivity gives the nature of the material of the conductor. So reason is true, but assertion is false. So option D is correct. ठीक है? Understood? Let's move on to the next question. My next question says, 3 cylindrical copper conductors along with their face areas as A by 3, 3A, and L, 3L and L by 3, compare the resistance. Oh, okay, this is a big question. Read it carefully. Okay? They are saying 3 cylindrical copper conductors. So we have 3 cylindrical conductors, right? And all these have along with their face areas as A by 3 and 3A. So their areas are A by 3 and 3A, right? This is A1, this is A2 and this is A3, correct? Then they have length as L, 3L and L by 3. So L1 is L, L2 is 3L and L3 is L by 3. Understood? We have written everything. Now compare the resistance and resistivity of the 3 conductors. Okay, so we have to compare the resistance and resistivity. Okay, let me know in the live chat what will happen to the resistivity. I'll tell you about the resistance, but what will happen to the resistivity? How will that be different? Okay? Now let's look at the very first again formula, that is resistance, rho L divided by A. So R1 is simply rho L divided by A. ठीक है? This is my resistance for the first formula, first case, right? Done. Then let's move on to the second one. For second one, we have R2 as rho L2 divided by A2, correct? Now this is rho is same. L2 is what? L2 is 3L, right? It is 3L and area is A by 3. Area is A by 3, correct? So R2 will be rho. Now this will be 3L A and this 3 will go up, correct? Understood? So R2 is 9 into rho L divided by A. आ गया समझ? Understood? Then moving on to the third part. Third part is R3 equals to rho L by A. Okay, this is the part. Now L here is what? L3 by A3. So L3 is L by 3, L by 3 and area is 3A. So R3 will be what? R3 will be rho L3 divided by 9 into A. This will be L, right? This is L3 divided by 9 into A. This also won't work. So this will simply be L and A. Okay? Understood? So this is the resistance for third case. Got it? Done? Yes. R by 9, R, 9, R. Very good. So you can just, if you think this is R, so R1 is simply R. R2 is 9 into R. And R3 is R by 9. Correct? Understood? Everyone clear? Resistivity shape और size पर depend नहीं करता, that's why will be the same. Very, very good. That is good. So resistance for each case will be different, but resistivity will not be different because in all the cases we are using single same copper wire, not the same but copper wire. So resistivity of copper wire will be same in each case no matter what its length or area is. Okay? There will be a session for bio as well, Mayank, that will be taken by Jasmine ma'am. Okay? Okay. Then moving on to the next question, we have an electric iron of 1500 watt. Okay, so these electricity questions, whatever questions are left, I am giving as a homework to you. We have done more than, I am thinking, 25-26 questions of electricity, right? So take a screenshot or let me know if you can right now, but take a screenshot. This will be your homework. Okay, I've done lots of questions of electricity today. This will be your homework. Okay, right? Moving on. Okay, we have this MCQs. Anyone wants to solve this? What is this MCQ saying? For verifying Ohm's law, we design an electric circuit diagram in which we show the arrangement of different circuit components. We find that with respect to resistor, ammeter is connected in parallel and voltmeter is connected in series. Ammeter is connected in series, voltmeter is connected in parallel. Ammeter and voltmeter are both connected in series. Ammeter and voltmeter are both connected in parallel. So what is the right answer for this? Okay, so we know that in the circuit, ammeter is always connected in series with the resistor and voltmeter is always connected in parallel. Ammeter is always connected in series and voltmeter is always connected in parallel. Voltmeter is always connected in parallel. Understood? Okay, next question. Again, this question is same, just like I've done before, a little bit difference, then you can do it. This is also your homework. Okay, let me know the answer. मैम मैं बोर्ड में फेल हो जाऊँगा. नहीं होगे मयंक. You just, if you haven't done anything, just sit in this live, solve these questions. These are very easy. I have done till 30 questions till now. It will be very easy. Just revise these. Okay? Okay? Next question, again an MCQs question, that is again an homework for you. Okay? Whatever I am giving as homework, let me know in the comment section of after this live ends. Let me know in the comment section what are the answer of all these questions that I am giving to you. Okay? Okay. Next, a complete circuit. Okay, this I'll tell you. A complete circuit is left on several minutes, causing the connecting copper wire to become hot as the temperature of the wire increases. So we have a copper wire, okay, and they are saying it is in a circuit and the circuit is left on for several minutes. ठीक है? When the circuit is left on several minutes, obviously the wires, they are getting heated up, of course, and as the temperature of wire increases. Now what will happen if temperature of wire increases? Temperature of wire increases. Now see, this is copper. This copper is, see how you approach this question. First of all, see, is copper a good conductor of electricity or not? Yes, yes ma'am, copper is good conductor of electricity. This is a good conductor of electricity, right? If it is a good conductor of electricity, that means for conductors, if temperature increases, the resistivity does what? Resistivity. What happens to the resistivity? Not the resistivity, resistance. That is my bad. What will happen to the resistance of the wire? Okay, let me know what will happen if I increase the temperature of copper wire. What will happen? Its electrical resistance will increase or decrease, or it remains the same, or it increases for some time then decrease. Its resistance, Shivansh is saying, increase. Oh, thank you beta, ma'am, आप बहुत अच्छी हो. Thank you so much. ठीक है? So this is true if for a conductor, if temperature increases, resistivity also increases. Done? For a conductor, this whole part is very important. For a conductor, if temperature increases, the resistance also increases. Done? Yes, it is directly proportional to R. Very good. Okay, moving on. We have one more assertion reason question. Let me know the answers. Electrical appliances with metallic body have 3 connections, whereas electric bulb has only 2 connections. Then reason is 3-pin connections reduce heating of connecting wires. Is that true? Is assertion or reason both true or not? Temperature increase होने से atom की kinetic energy increase हो जाती है. Very good. And because of that, collision increases. मैम आप क्या क्या पढ़ाते हो? आई टीच फिजिक्स हियर ऑन दिस चैनल. आई टीच फिजिक्स. ठीक है. अरे दे तो दिया आंसर, फिजिक्स पढ़ाते हूँ. चलो. नाउ what they are saying, electrical appliances with metallic body have 3 connections. That is true. We know metallic bodies, the charge resides on their surface, and as some water or we touch that, as it gets wet or it touches the outer air, the charge resides on the metal, and if we touch that metal we can get shocks, right? So for that a 3-pin plug is used. What this third pin is for? This pin is connects to earth wire. Now what this earth wire does? Earth wire transfers all that charge. This is a metallic body, this is charge on that metallic body, right? So it transfers all that charge back to the earth. We call it grounding. So it transfers all the charge back into the earth. That means now there is no charge on the metallic body, and hence we don't get shock. Okay, now we don't get shocks. So assertion is correct that metallic body have 3 connections where bulb has 2 connections. But the reason 3-pin connections reduce heating of connecting wires, that is not true. 3-pin is used to transfer the excessive charge to the earth. It is not used to reduce the heating of connecting wires. So assertion is true, but reason is false. Assertion is true, reason is false. Biology पढ़ाओ, मेरा biology weak है. Biology is taught by Jasmine ma'am. She is a really great bio teacher. She will also take your lives. There are lectures of her on our channel as well. You can watch them. She will also come take your live, okay? Very soon. Okay. Next question. The values of, okay, this is also your homework. Again, one electricity question. This is your homework. The values of current I flowing in a given resistor for the corresponding values of potential difference. You are given some values of current and some values of voltage. Plot a graph between V and I. We need to plot a graph between V and I. Now that is very simple for you guys. I know you know how to plot a graph. ठीक है? Plot a graph, calculate the resistance of the resistor. So slope of this graph will give you the resistance of this circuit, right? Slope of the graph will be equal to resistance of the circuit if you take V at y-axis and I at x-axis. ठीक है? पर मैम what I decrease होता है तो भी decrease होगा. Yes. I can't read you. क्या है यार? Free fire. I cannot read the actual comments. लेकिन मेरे को आपसे पढ़ना है मैम. Okay, I'll see. Okay, I'll let you know. Okay. Let's move on to the next. Okay, magnetic chapter. We are on to the chapter magnetic effects of electric current. Now this chapter is very important again, but it is not highly based on numericals. It is highly based on conceptual questions, left hand rule, right hand rule, factors affecting the magnetic field around a current carrying conductor, different magnetic fields, different direction of magnetic fields, different concentration of magnetic fields, different shapes of magnetic fields due to different kinds of conductors, we'll study in that chapter, in this chapter. Okay, we have put on all the videos, we have one shots, rapid revisions, quick summary of all the chapters on our channel. If you want to revise this channel first, you can go watch them whenever you get the time. Today we will be solving the questions of this in this live. Okay, and you can ask your doubts directly to me in the live chat. ठीक है, समझ गए? Notes, yes, notes will be provided to you. I'll provide the notes of this lecture as well. ठीक है, with the solution. With the solution, I'll give you the notes. Okay. Assertion says two magnetic field lines around a current carrying straight wire do not intersect each other. Correct? So assertion is very basic, ma'am. This is one of the most basic property of magnetic field, that is the magnetic field, two magnetic field lines around a current carrying straight wire do not intersect each other. Magnetic fields in general anywhere does not affect each other. Okay, so reason is the magnitude of the magnetic field produced at a given point increases as the current through the wire increases. Okay, see, that is now correct or not? That is also a correct point, that magnetic field of the magnitude of the magnetic field produced increases with increase in current, but this is not the correct reason for assertion, right? So option B will be correct. Both assertion and reason are true, but reason R is not the correct explanation of assertion A. Done? Done till here? Next question. Name the device used to magnetize a piece of magnetic material. Draw a labeled diagram to show the arrangement used for the magnetization of a cylinder made of soft iron. What they are saying? Name the device used to magnetize a piece of magnetic material. So in the question we have, in the chapter we have studied, what we have studied? The solenoid. We have studied solenoid, right? Now solenoid, what is a solenoid? It is just a wrapping of insulated copper wire, and when current flows through that insulated copper wire in circular ways, in circular structure, that whole structure is called solenoid, and when current flows through it, a magnetic field is generated around it, because that is, in general we have studied that magnetic field is generated because of the flow of current. So when an insulated copper wire is wrapped in circles, something like this, then this structure is called solenoid. Draw a label diagram to show the arrangement used for the magnetization of a cylinder made of soft iron. Now this is important. What happens? We take a soft iron core. This is a cylindrical soft iron core. What we do is we insert that core inside this solenoid. So technically we are wrapping that insulated copper wire around the soft iron core. Let's say this is my soft iron core, and we are wrapping the copper wire in very close structure. We are wrapping that copper wire around that iron core, right? So this iron core, because there is a current flowing in this solenoid and a magnetic field is generated, this iron core, it gets magnetized. It gets magnetized. Correct? Show the arrangement used for the magnetization of a cylinder made of soft iron. The negative part of the battery here will be north pole. The positive part of the battery here will be south pole. From negative, north pole. Understood? Okay. Next question. Next question says, draw the pattern of magnetic field lines of a current carrying solenoid and a bar magnet. So we have to draw the magnetic field lines of a current carrying solenoid and a bar magnet. What is? This is solenoid. This is solenoid, and for bar magnet. Okay, so first of course I have to draw a solenoid, right? This is my solenoid. The positive part of the battery will make a south pole in its direction. The negative part of the battery will make a north pole. I remembered this, like the negative and a north both have N, right? So negative north and hence positive south. Okay, so now to make the magnetic fields, what will happen? The magnetic field lines will be something like this around the solenoid. Similarly, below the solenoid. And what will be their direction? Their direction, ma'am, their direction will be outside north to south, outside north to south, right? Inside south to north. Correct? Understood? Very basic diagram that we have studied all through our 10th chapter, 10th class. Okay? Okay. Then bar magnet. For bar magnet, this is the first thing we have studied, ma'am. This is my bar magnet, right? And this is, let's say, north pole, and this is south side, right? So what will be the magnetic fields? It will be similar. It will be something like this, right? The magnetic fields will be something like this. Outside it will go from north to south, and inside they will go from south to north. Understood? Magnetic field lines for both a bar magnet as well as a solenoid. Is that clear? ठीक है? Then moving on, we have the next list. One distinguished feature between two fields. देखो, one distinguished feature is this solenoid. If we change the polarity, here in bar magnet, this is a permanent magnet, right? Bar magnet is a permanent magnet. Understood? Bar magnet is a permanent magnet. It is a permanent. It is a permanent magnet, right? But solenoid, magnet formed due to the solenoid will be a temporary one. Will be a temporary one. Will be formed, right? Now the one feature that is between two fields is, now I know that if I change the polarity of this battery, the north pole and south pole will switch, and if the north pole and south pole will switch, ma'am क्या होगा अगर magnetic field lines attached together? They will never attach together, Abhishek. Magnetic field, it is their property that they will never ever attach together. Okay? So if I switch the polarity of this battery, the north and south pole will switch, and if north pole and south pole switches, that means direction of magnetic field changes. So its polarity can change. Or you can write the direction of magnetic field lines can change. But here polarity is changed, not changed, so direction of magnetic field lines can't change. They can't change. Understood? सोलेनॉइड के इनसाइड यूनिफॉर्म फील्ड होती है और बार मैग्नेट के नॉन यूनिफॉर्म. हु टोल्ड यू बार मैग्नेट के अंदर नॉन यूनिफॉर्म फील्ड होता है? बार मैग्नेट इज ऑल्सो bar magnet also has uniform magnetic field inside it. Shivansh. Okay. Hi Prachi, Radhe Radhe. Okay. Next question we have: for a current in a long straight solenoid, north and south poles are created at two ends. Okay. Among the following statement, the incorrect statement is what? The field lines inside the solenoid are in the form of straight lines, which indicates that magnetic field is same at all points inside the solenoid. So this is my solenoid that we just made. This is we just studied it, and we know that inside the solenoid magnetic field lines are uniform. Inside the solenoid the magnetic field lines are uniform. Make sure they don't touch each other or they don't cross each other. Fine. Whenever you are drawing, north to south, north to south, south to north. Now, whenever inside the solenoid magnetic fields are uniform, so first point is true. We have to say incorrect statement. Okay. Sorry. Second is, the strong magnetic field produced inside the solenoid can be said to magnetize a piece of magnetic material like soft iron when placed inside the coil. That is also what we just studied, right? If we place a magnetic iron core inside a solenoid, it will get magnetized. A strong magnetic field produced inside solenoid can be used to magnetize a piece of magnetic material. So this statement is also true, right? The pattern of the magnetic field associated with the solenoid is different from the pattern of magnetic field around a bar magnet. Okay, this is a questionable statement. But ma'am, we saw in the last question that for solenoid and bar magnet, both the magnetic field lines are similar, right? They form closed path, they are in the same direction, they are forming the same kind of loops. So this statement, my friend, is not true. That is C statement. Okay? D, let's see, the north and south poles exchange position when the direction of current flowing through the solenoid is reversed. That is true. Now the direction of current is in this side. If I change the polarity, the direction of current will be that side, and hence the direction of magnetic field lines will also change. So this part is also true. C is the correct answer for this particular question. Understood? Okay, what are you guys even talking about? Okay, let's see. These are, what is the difference between bar magnet and an electromagnet? It's a very important question, very asked question repeatedly in your boards, okay, in your PYQs. So what is a bar magnet? We just said bar magnet is a permanent magnet. Electromagnet, on the other hand, is a temporary magnet. Then it does not require electricity. Of course, bar magnet functions on its own. Even if you don't provide it any electricity, it will function. So it does not require electricity to produce magnetism. On the other hand, electromagnet requires electricity. It requires electric current to produce magnetism. Okay, then its magnetic strength, the magnetic strength of bar magnet is fixed and cannot be changed, but magnetic strength of electromagnetic can be increased if we increase the current, right? So its magnetic strength can be changed. It cannot be switched on or off. Every time bar magnet will attract the iron fillings if they are sprinkled around it, right? But it can be electromagnet. If you switch off the battery of the solenoid, electromagnet will lose all its magnetism properties. Okay? Someone is saying bye. Okay? Now, made of hard magnetic materials like steel. Bar magnet is made up of steel. On the other hand, electromagnetic is made up of soft iron core with a current carrying coil. Okay, these are used in compasses. Obviously, we cannot provide electricity to compass when you are lost in jungle. Fridge magnets, of course, and toys. These are used in electric bells, relays, cranes, motors, etc. Okay, done. Okay, everyone, I know you guys are chatting in there, but go subscribe the channel, and also I want you to join this WhatsApp channel. This is very useful for you. We come live every day for 4 to 5 hours, 3 to 4 hours. We are solving all the PYQs, bringing all the summary for you, and you will get the notifications on our WhatsApp channel. Of course, okay. So if you don't want to miss it, there is a link in the description. You can, Ashish, there is a link in the description. You can go and join the WhatsApp channel. Okay. 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 Moving on, and like this session and subscribe the channel. Like this session, please. Go ahead, like the session. Okay. Okay. Moving on, we have next question. This next question says, a constant current flows in a horizontal wire in the plane of paper from east to west. See, here they have written in the plane of paper. Now, this plane of paper word is very important. So, you have a plane of paper, something like this, and in there a wire is placed, something like that, right, from east to west, and the current is flowing from east to west. Understood? Current is flowing from east to west. The direction of magnetic field at a point will be north to south, directly above the wire, directly below the wire, at a point located in the plane of the paper on the north side of the wire, at a point located in the plane of the paper on the south side of the wire. Now, you have to understand this on the basis of a paper, not the board, right? So this is a paper and this is a wire. So current is going in that direction, right? Right? We need to find the direction of magnetic field. Now, when they're saying above the wire, it's not in this part. It's this part, right? And it's this part below the wire, okay? So, when you have to find the direction of magnetic field, we use right hand thumb rule. We use right hand thumb rule in case we have to find the direction of magnetic field. To find the direction of magnetic field. Now, this is north, this is south, this is east, this is west, right? North is not above, north is here because it's a piece of paper they have placed the wire on. East, west, north, south. So they are saying where the current goes from north to south. So I'll place my thumb in the direction of current, something like this, and I'll curl my fingers. So below the wire, can you clearly see? Below the wire, the current is growing from north to south. Below the wire, the current is going from north to south. Understood? So the option is directly below the wire. Done? Okay. Moving on to the next question, we have the pattern of magnetic field produced inside a current carrying solenoid. We are done with this. So this is your homework. Practice this, right? We have drawn the magnetic field due to a current carrying solenoid multiple times in this live only, right? So go watch that if you want. And this is your homework then. Okay, subscribe the channel, of course. I've gave you lots of gyan on that. Then, the next question, this is very important question. It has been come in boards 2023 and it's been repeated again. Okay. Hi, good afternoon, Tushika. Okay, so we are doing a question from the chapter Magnetic Effects of Electric Current. Okay? So the question says, state the rule used to find the force acting on a current carrying conductor placed in a magnetic field. right? Now we have to find the rule to find the force acting. Now what did I tell you? Whenever you have to find the rule, whenever you have to find the direction of force, then we use, from force F, we use Fleming's left hand rule. Fleming's left hand rule. Done? Understood? Now what is Fleming left hand rule is what we have to state. Fleming left hand rule states that if you point your index finger in the direction of magnetic field and then stretch your index finger perpendicular to your index finger in the direction of current, then this thumb will give me the direction of force. Exactly. So this is 3 parts. This is my thumb. This will give the direction of force. Index finger will give me the direction of magnetic field, and this middle finger will give me the direction of current. Understood? Will give me the direction of current, provided they are stretched at 90-degree angles. Now in this case, identify the case in which the force will be maximum and minimum respectively. See, in this case you don't necessarily have to do with the direction but more with the formula. Okay? So formula for this force is QVB sin theta, where theta is the angle between V and B, the velocity of the charge and magnetic field. Understood? So when sin theta is maximum at an angle of, sin theta is maximum for an angle for a theta of 90 degrees, and it is minimum for the angle of 0 degrees, because sin theta is 1 and sin 0 is 0, right? Understood? So in this case, electron is going upwards, magnetic field is in this direction. So the magnetic field, this electron is making an angle of 90 degree clearly with magnetic field, right? In this case, the electron is making an angle of 0 degrees, right? And this is just making a random angle, right? This is making a random angle with the magnetic field less than 90 degree, maybe 30, 40, 60, whatever. Okay? Now, this is a case of 90 degree. That means the force will be maximum for this case. The force will be, in this case, when electron and magnetic field are at 90 degree angles, that means F equals to QVB sin theta. That means QVB sin 90, correct? And that will be QVB into 1. So force will be QVB. Understood, everyone? Then in the third case, electron and the magnetic field has an angle of nothing, it has angle of 0. Then the force in this case will be F equals to QVB sin 0 now, right? So that will be QVB sin 0 is 0. So force is 0. So the force is minimum in case of, the force is minimum in third case. The force is minimum in third case and it is maximum in the first case. Understood, everyone? Understood, everyone? Okay, let's move on to the next question. The next question says, read it very carefully. The next question, yes, this is an assertion reason question. The assertion reason question, next question says, the strength of magnetic field produced at the center of a current carrying circular coil increases on increasing the number of turns on it. Okay, that seems to be true. The reason says the current in each circular turn has the same direction and the magnetic field due to each turn just adds up. That is true, my friend. The assertion says that yes, the strength of magnetic field will increase as you increase the number of turns. In this case, number of turns are more. In this case, number of turns are less. So in this case, magnetic field is definitely more, and in this case, magnetic field is definitely less. Understood? So the strength of magnetic field produced at the center of a current carrying coil increases on increasing the number of turns. Assertion is true. Reason says the current in each circular turn has the same direction and the magnetic field due to each turn just adds up. See, this is a current going upwards, coming downwards, going upwards. Let me just show you. So see, this is my coil, right? What is happening is that the current is going upwards, it is coming downward, going upwards, it's going here, it's coming down, going upwards. So these two are parallel to each other, right? These two are parallel to each other. So the current in each circular term has the same direction. It goes down, goes up, goes down, goes up, goes down, goes up. And since they are in same direction, so the current adds up. So both A and B, A and R are true. And R is the correct explanation of assertion. Okay? Done? Moving on, we have a next question, a very important question that says the resultant magnetic field at a point P situated midway between two parallel wires, each carrying a steady current, is what? In the vertically upward direction, in the same direction as the current in the wire, 0 in the vertically downward direction. So we have to find the magnetic field. We have to find the magnetic field at point O. This is at point P. So this is what we have to find. And it is situated midway, right, between two parallel wires, each carrying steady current. Now, if you cannot see, there are arrows which are pointing that the current is in same direction. Okay, now we have to decide what will be the magnetic field at the point P. So we use right hand thumb rule whenever we need to find the direction of magnetic field. We use right hand thumb rule. Understood? We use right hand thumb rule. Correct? So this is my right hand. I place it in the direction of current. So this is current and it goes inside and it comes out. They are in circles. So at this point it's going in, at this point it's coming out. It is coming out of the board at the point P, right? It is coming out of the board at the point P. This is the direction, if I do it, then this is going inside. At point P, due to the down wire, the current is going inside. Now the current is similar, current is same, but in the both directions, and the direction is also same. So due to that, the direction of magnetic field lines is different. For above wire, the current is coming out. For down wire, the current is going in. Now since the value of magnetic field will be same, so that means at point P, the net magnetic field will be what? It will be 0. Understood? it will be 0. So C is the correct option. Understood? Moving on to the next, we have, can you name all these points very quickly? What are these points exactly? PQ, is it south or north? RS, is it south or not? Name these points very quickly, come on. Name these points if P is a south pole or a north pole, if Q is a south pole or a north pole. Let me know. Okay, so hi Sakshi, Radhe. Let me know what are the points, what are the poles of these points. P, Q, R, S. Are these north pole? Are these south pole? Right? So what you have to actually see in this case? You have to see the direction of magnetic field lines. You have to see the direction of magnetic field lines. Very easy. We know from north to south outside the magnet, outside the magnet, and the direction of magnetic field lines is south to north inside the magnet. Understood? Inside the magnet, right? So from P the rays are going out. The rays are going outside. So P is hence rays are going out, right? We can clearly see these arrows are going out. So P is north pole. Understood? P is north pole. सबसे पूछे जा रहा है, जैसे लड़की आ रही है सबसे पूछे जा रहा है कि तुम कहाँ से हो, तुशिका तुम कहाँ से हो, साक्षी तुम कहाँ से हो, ये करने आते हो? Okay, Q, the lines are going in. At Q, the lines are going in. So if lines are going in, that means it is a south pole. Understood? That means it is a south pole. Okay? Now, and this is the figure number A. Correct? For figure number B, we can see clearly. That here the lines are going inside. Inside, they are traveling from R to S. Now inside lines go from south to north. That means R is a south pole. Understood? R is a south pole and S, my friend, is a north pole. Understood? Clear? Till here, any doubt if you have? Till here, any doubt if you have, you can ask. Okay? Hi Prashant. Okay, any doubt? Gujjar sir aa gaye. You are so proud. Okay, let's move on to the next question. ठीक है, देखो, the next question says, we have the answer, so I'll just read it to you because I put it in a PPT and all the animation and stuff and it didn't work. Okay, distinguish between the term overloading and short circuiting. So, short circuiting in a broader mind, hi Lavish. So, in broader mind, short circuiting is what? When live wire comes in direct contact with the neutral wire, that means red wire with the black wire. When they come in direct contact, lots of current flows into them and that definitely harms our appliances, and that is what we call short circuit. Right? Understand? Then overloading. You have seen those multi-plugs. If you connect your fridge, your computer, your charger, your lights all to a single plug, then that case is called overloading, because it is demanding a lot of current than that is actually present in the circuit, right? Correct? Ma'am, आप कहाँ रहती हो? Right now I am away from home, but I am from Punjab. Where are you guys from? ठीक है, बताओ फिर. I am speaking from like 3 hours. हाँ बेटा, doubts पूछो ना. I am from Punjab, Punjab Lavish. अरे पूछ तो भाई. चलो. So overloading, it occurs when too many electrical appliances are connected to a single circuit. It occurs when too many electrical appliances are connected to a single circuit. Oh, we have people from Karnataka. Hello. ठीक है? It occurs when too many electrical appliances are connected to a single circuit and draw more current than the wire can safely carry. समझ में आया? ठीक है? Human eye. We are going to do human eye as well. We will be doing questions for human eye in this live also. ठीक है? So wait for a little bit. Then overloading, the total resistance of the circuit becomes low, and because many appliances work together, increasing the current. Okay? Because all the appliances are connected in parallel, as they are connected in parallel, the resistance drops, and as the resistance drops, current increases. Done? It causes overheating of wires and may lead to melting of insulation. Done? Then last point, it usually happens when high power devices like heater, AC, iron are used together on one socket. This point is very important. ठीक है? One socket. Current increases gradually. ठीक है? मैम मेरा नाम ले लो. अपना भाई आलोक. हाय आलोक ले लो. Not PEDS ने दे दिया. Okay, short circuiting, it occurs when live wire and neutral wire comes into direct contact. That's what I said, due to the damage or insulation failure. The resistance becomes very low, almost zero, causing a sudden surge of current. Then it produces a very large current suddenly, which can cause sparks, it can cause fires, damage to our appliances and all. ठीक है? Then it usually happens due to the broken wires. Of course, when the wire is broken, they can come into direct contact. Broken wires, loose connections or damaged insulations. Current increases instantaneously and violently. Okay? Done? Then next question says, show the polarity acquired by each phase of the solenoid. This is very easy. The one thing you need to remember, this is my solenoid. Just have to look at the battery. This is my battery, right? Just have to look at the battery. This is positive side, this is negative side. Now from negative, the negative side will have north pole, correct? N and negative north. So at negative side, this will be north. So hence the positive side will be south. Very easy. Okay? Done? सब appliance तो share कर दो. पढ़ मत लेना. Draw the magnetic field lines of force inside the coil and also show their direction. So whatever, this is just the magnetic field lines. We have to show the magnetic field lines inside the solenoid. We drew it a lot of the times in this live. So make sure they do not touch each other. Make sure they do not cross each other, because we know magnetic field lines can never intersect each other. Outside they goes from north to south, inside they go from north to south. Very, very easy. Very easy. Okay? Okay. Done? Understood? ठीक है. Then next question says, mention two methods to increase the strength of a magnetic field inside the coil. Do you know two methods to increase the magnetic field inside the solenoid? Okay, inside the coil, coil is solenoid. ठीक है, coil ही solenoid है. ठीक है. Now, two methods क्या है? To increase the current. This is a foolproof method to increase the current, and it is valid not just for the solenoid but for every current carrying conductor in the coil. Done. The second method is, first is this, second is this, to increase the number of turns of insulated copper wire. It is very important to write this word insulated, right? Insulated copper wire. Done. हाँ भाई नितिन, ले तो लिया सबका नाम. मैम आपका कौन सा लेंस है, कॉनकेव और कॉन्वेक्स? सी आई हैव कॉनकेव लेंस. Yes, I have myopia because I cannot see distant objects clearly, and that's why this is concave lens. ठीक है? Okay. Moving on to the next. State the factors on which the resistance of a cylindrical conductor depends. अरे बताया तो दिया कौन सा लेंस है. ये नितिन सबको हाई करेगा आज. किसी ने लिखा है लड़की बाज. ठीक है. मैंने नहीं बोला है नितिन, मैंने नहीं बोला है. आई एम जस्ट रीडिंग द कमेंट्स. यार तुम मेरे से ये पूछने आए हो कि मेरी शादी हो गई है कि नहीं हुई हैं? पढ़ो चुपचाप. चलो. State the factors on which the resistance of a cylindrical conductor depends. How will the resistance of a conductor change if it is stretched or its length is doubled? ये इलेक्ट्रिसिटी का क्वेश्चन यहाँ कैसे आ गया? चलो, आ गया तो आ गया, we can solve it. ठीक है. तो क्या करना है? How do we start? State the factors which the resistance of a cylindrical conductor depends. Resistance बोलना है. Whenever resistance comes, resistance is always rho L by A. A very important, very easy formula that we have crammed by now all through our 10th, that is R equals to rho L divided by A. So, on what factors does it depend? This means the resistance, it depends on length of the conductor, understood? Then it depends on area, but which area? Area of cross section of that wire or conductor of wire. ठीक है. And then third, it depends on resistivity of the material. Resistivity of the material. Material कौन सा? Material of conductor. Material of conductor. Understood? These are all the factors on which resistance of a wire depends. Hello Tushar. Ma'am, please don't take long lectures. Also speak in English. Break the video into more sessions so that it would be good. Yeah, actually we have those as well. We have smaller sessions on our channel as well. We have taken live for just each chapters, from just electricity, light, magnetic effects of electric current, human eye. We are done with that, but as your boards are approaching, so we are trying to cover the whole syllabus so that you can sit in just one time and cover everything, right? या बोलने में कुछ नहीं जाता है. It's fine. ठीक है. चले next. So how will resistance of a conductor change if it is stretched so that its length is doubled? देखो, now the first keyword here is stretched. It is stretched, my friend. कहाँ गया? ये रहा, stretched. ठीक है? Stretched means if length increases, then area will decrease. Okay? If length increases, this area will decrease. Okay? So now the length is doubled. Correct? The length is doubled. For the first, L1 was L, but now L2 is 2L, right? So area of cross section was just A, but since it is stretched, area of cross section will decrease by the same magnitude. It will be A by 2. If the length was increased to 3L, area will be A by 3. ठीक है? Done? So R1 for this will be rho L1 by A1, that is rho L by A. Understood? So R1 is rho L by A. Get it? Done? This is the first point. Now moving on, this is for R2. R2 is rho L2 by A2. The resistivity is same because the material is just stretched. It is the same material, and for same material resistivity is always same. ठीक है? So R2 will be rho L2 is now 2L, right? So this is 2L, area is A by 2, so this will be 4 rho L by A. Now L by A is my R1, so R2 is 4 times R1. Understood? R2 is 4 times R1. So hence, how will the resistance of a conductor change? Resistance of a conductor will become 4 times of its initial resistance if the length of, if this conductor or this wire is stretched to twice of its length. Oof. ठीक है? Done? अरे क्या कर रहे हो यार? ठीक है. Next question says, hey, don't make anyone feel uncomfortable. ठीक है? If you are here, you need to study. I can't make you go. I can't make you leave the session. But do not make anyone feel uncomfortable. Okay? It's a humble request. Okay. Magnetic field lines are shown in the given diagram for a current carrying solenoid. A student makes a statement that the magnetic field at P inside the solenoid, so P is actually inside the solenoid. P is actually inside the solenoid. This is P, okay? And Q outside the solenoid. So Q is something here. I guess there is a problem with some diagram or something. Yeah. So explain with reason if student's claim is correct. So student is saying that the student makes a statement that the magnetic field at point P is stronger than at point Q. He says the magnetic field at point P is stronger than magnetic field at point Q. P is inside the conductor, Q is outside the conductor. Now I know outside the solenoid. So let us write some basic rules. Now I know inside the solenoid, the field is uniform. There is a uniform magnetic field. Get it? Then outside the solenoid, the field is not a uniform, but the field is non-uniform. Understood? The field is non-uniform. Correct? So if you say that inside P is more than outside Q here, then that is correct, because as we go away from the solenoid, the intensity or the strength of magnetic field decreases. See, magnetic field is inversely proportional to distance, right? So as we go away from the As we go away from the solenoid, the magnetic field strength will decrease. So at P, the magnetic field is definitely stronger than Q. So his claim is correct. His claim is correct. Done. Also redraw the diagram and mark the direction of magnetic field lines. So we have to redraw the diagram. This is current carrying solenoid. Yes. So this is a conductor that is placed, and around it a copper wire, but insulated copper wire is wrapped, which is then connected to the battery of voltage V. Now magnetic field lines will be something like this, very similar to bar magnet. These are closed. Where did I go? These are closed, so make sure you close them, just like here. Don't do this mistake. And inside and below this, similar. Okay. Now negative part of the battery makes north pole, positive part of the battery makes south pole, right? It makes south pole, correct? So north to south, this is north pole, this is south pole. Outside, the field lines will go from north to south. Inside, the field lines will go from south to north. Outside, north to south. Inside, south to north. Clear? This whole diagram is clear. ठीक है? Done? Okay. पंगा मत ले. चलो. What is meant by magnetic force? What is meant by magnetic force? Magnetic force. So we have a magnet. Now there is a region around the magnet in which we experience force. There is a region around the magnet in which the magnetic materials will face the pull, right? Will feel the pull, correct? So in that area, in that region, that magnetic material or iron fillings or copper will experience the pull or push of the magnet. That is called magnetic force. Done. Force experienced by a moving electric charge or a current carrying conductor. Moving electric charge or a current carrying conductor or a magnetic material which is placed inside a magnetic field. Done? Understood? Right? Then how does this force gets affected on doubling the magnitude of current, on reversing the direction of flow of current, on reversing the direction of magnetic field? See, we are seeing the force. Now force has two formulas in this chapter, that is either QVB sin theta, or it has similar but ILB sin theta, correct? So what is the first point? Doubling the magnitude of current. As the magnitude of current doubles, the force also doubles. So what happens? Force will double. Correct? Understood? Then second is reversing the direction of current flow. When you reverse the direction of current, the direction of force will also change, right? Because if I and B are in same direction, so theta will be 0 degree, right? But if they are in different direction, theta will be 180 degree. If the direction of I is reversed, theta becomes 180 degree. That means now the direction of force is reversed as well. Okay? Then the third is reversing the direction of magnetic field. Similar to here, theta will be if 90, then if you reverse, the theta will be 270. So it again reverses the direction of force. Reverses the direction of force. Correct? अंडरस्टूड? क्या पंगा लेना है, पता नहीं कौन कौन पंगा ले जा रहा है कमेंट में. ठीक है, डन. चलो नेक्स्ट क्वेश्चन. बहुत हिंसा हो रही है आज कमेंट सेक्शन में. ठीक है, ओके. Guys, we'll just take a break for 5 minutes. Okay, I'll just come back in 5 minutes. You solve these questions, let me know the answer of this question in the live chat, right? I'll be back in just 5 minutes. Okay, then we'll continue the rest of the session. There is a lot of session left, so we'll continue the rest of the session. Be present and let me know the answer. If you want to take a break also, you can take a break. I'll be back in 5 minutes. Okay. with the full josh. उठ जाओ सब उठ जाओ. Whoever has slept in the break, सब उठ जाओ. तो शुरू करें. Next question. Whoever is present, let me know. Mark your presence that ma'am we are still here. ठीक है, शुरू करें. चलो. We are moving on to the next question. The question is, study the diagram below and answer the questions that follow. Okay, this is the diagram that we have to study, right? And then we have to give answer to the following questions. Done? Why do the iron fillings arrange in such a pattern? देखो, all these questions are theory based. ठीक है? So I'll give you itty bitty here and there the pointers on where to write, on what to write, right? And you have to form the question, right? You know English, I know. Okay? Why do iron fillings arrange in such a pattern? Ma'am, iron fillings actually they arrange themselves in the pattern of magnetic field lines, right? They arrange themselves in the pattern of magnetic field lines around the magnet, correct? Now, as this gives the direction of, this gives the shape of magnetic field lines. Understood? Good. So that is why these iron fillings depict the shape of magnetic field lines. Then what does this pattern demonstrate? This is, again you can write, this demonstrate the shape of magnetic field lines around the magnet. Done? The shape of magnetic field lines around the magnet. Then third is, why do the iron fillings near the magnet seem to align in the shape of closed curves? See, here they are seemed to align in closed curves. That is true, ma'am. We know why this happens, because the shape of magnetic field lines are closed curves. Magnetic field lines are closed curves. They travel outside from north to south, and inside they continue to travel from south to north. So they form a complete loop. These are the magnetic fields, right? Understood? Okay, moving on to next question. We have PQ is a current carrying conductor. PQ is a current carrying conductor. Done? In the plane of paper as shown, okay, find the directions of the magnetic fields produced by it at point R and S. What is the direction of magnetic field at the point R and S? See here, I think they have forgot or they haven't mentioned the direction of current. So let's say the direction of current is in upward direction, right? The direction of current is in upward direction. Now I need to see the direction of magnetic field lines, magnetic field. So I know, ma'am, direction of magnetic field, direction, to find the direction of magnetic field, we use a rule called right hand thumb rule, correct? Right hand thumb rule. Understood? Right? So we'll use this right hand thumb rule on this side. So if I is pointing upwards, correct? Let me know if you are understanding this. If I is pointing upwards, so my thumb will point in the direction of current, that is upwards. And if I curl my fingers, then at the curling of my fingers will give the direction of magnetic field, that is inside the, at our point, it is inside the board or it is inside the paper. Done? It is inside the this whatever board or paper that is there with you, right? Now the same are coming outwards. Here they are going in and they're coming out. So at a point S, the magnetic field line will be, the direction of magnetic field lines will be outwards. So at R, the magnetic field lines are inwards, and at S, the direction of magnetic field lines are outwards. Inwards is depicted by cross sign and outwards is depicted by O sign. Done? Understood everyone? Hello Kailash. How are you doing? Okay? Understood this question, right? Now they are asking one more pointer. Okay, they are saying given R1 is greater than R2, this is my R1 and this is R2. Definitely ma'am, we know R1 is greater than R2. Okay, now what is the question? The question is, where will be the strength of magnetic field will be larger? We need to see where will be the strength of magnetic field is larger. Hi Ashish, I know Abhi ho, you are in the life from a lot longer. I know. Then, so they are asking at what point, R or S, at which point the magnetic field strength will be larger, right? So I know magnetic field strength is inversely proportional to distance, right? It is inversely proportional to distance, correct? This is the one of the main factors on which magnetic field depends, correct? So as R1 is greater than R2, that means magnetic field at R2 will be greater than magnetic field at R1. Understood? Understood this relation everyone? Okay, let me know if you understand. I'm fine man. What about you? I'm great Kailash. Okay, you understood this question? Can we move on to the next one? Everyone, let me know if you understood this question, and I'm moving on to the next one. The next one says, if the polarity of a battery connected to the wire is reversed, there is a battery that is connected to the wire. Now, if they are saying if their polarity is reversed, how would the direction of magnetic field be changed? Let's say this is some wire. This is my wire. Now, the polarity of a battery that is connected to this wire is changed. That means this wire is same, right? But the polarity of battery is changed. Correct? Understood? Here the current was in this direction, right? But here the current is in downwards direction. Understood? Everyone? Understood? Now, they are saying if the battery is connected to reverse, so we reversed the battery, right? Then how would the direction of magnetic field will be changed? So ma'am, the magnetic field direction will also be reversed. Okay, now see how. This is for your understanding. Listen to it very carefully. This is the current. So here current is going downwards. Current is going downwards. That means the magnetic field is in this direction. It is going in from here, coming out from here, right? It is going in from this side and coming out from this side. But in this case, the current is in upward direction. So in upward direction, it is going in from this side and coming out from this side. Going in and coming out. Understood? So what did we see? The direction of magnetic field will also be reversed. Okay? Understood? Then this is the first part. Moving on to the second part. Second part says, क्या कह रहे हैं जनाब? Explain the rule that is used to find the direction of the magnetic field for a straight current carrying conductor. This is what we used, right? This is right hand thumb rule. This is what we used here. This is right hand thumb rule, and it states that if you point your thumb in the direction of current, then curling of your fingers, ma'am, will give the direction of magnetic field lines. Okay? If you point the thumb in the direction of current, the curling of fingers will give the direction of current, direction of magnetic field lines. Understood? Done? Moving on to the next question, we have draw the magnetic field lines including field direction of the magnetic field due to a circular coil of current. We are done with solenoid, we did bar magnet, now we will do circular coil of current. Okay. मतलब आपसे कहाँ से ज्वाइन हो सकते हैं? What do you mean by that, Ashish? Okay, focusing on that. Until that, you let me know what do you mean by that. So, draw the magnetic field lines of a magnetic field due to a circular coil of current. See, we have a circular coil of current. Do I have a circle with me? I do have a circle with me. So, this is a circular coil of current. Let's say in first case, is this, can I use this? Just a second. See, this is a circular coil. Okay. Now, let's say the first case is that the current is clockwise. The current is clockwise in this coil. Right? So, the current is clockwise, that means it is going like this and it is going like and it is going like this. Understood? I teach here, beta. You can come in the live sessions anytime you want. You can also comment down, I'll see. You can join our WhatsApp channel and you can contact us all on these channels, okay? Okay, so the current is in clockwise direction. Fine. Now current is in clockwise direction, so we will use right hand thumb rule. Why we are using right hand thumb rule? Because for right hand thumb rule is used, why am I saying like this? Right hand thumb rule is used to find the direction of magnetic field lines. Okay? Done. So, what is happening? The current is upwards. If you zoom it, I don't know how to zoom it actually here, but if you zoom it, oops, nope. Okay? Now, what happens if you zoom it? What will happen? yaar. Did something. Is this not correct at all? I don't know how to correct this. Okay, let's just work with this. It is good now, right? Okay, so let me just see. Right, so the current is in which direction? The current is in clockwise direction. Is the screen right now? Yes. So the current is in clockwise direction. We will not try to zoom in this time. Okay? So current is in upward direction. Right hand thumb rule. The magnetic field lines are going in from this side. They are going in and they are coming out. See, for O we use dot for outwards. Okay? Okay? Hi everyone. Deeksha. Ashish is saying hi to Deeksha. So it is going in and it's coming out. At this point, the eye is this is downwards. So we'll point our thumb in the downward direction, right? In downward direction, and we'll curl our fingers. And at this point, it is inwards, and at this point, it is outwards. The magnetic field is outwards. Okay? So for clockwise, inside the coil, the direction of magnetic field lines, magnetic field will be inside. Done? Understood this part? Okay, thoda fast. Okay, yes. Then if now you change it, right, you change the direction of current. Let's say now the direction is anti-clockwise, right? The direction is anti-clockwise. What will happen? So the current is this. Now again we'll use right hand thumb rule. Above it is going, this is downwards. So here it will be coming down. Here we are pointing the thumb in the downwards direction. It's going in, coming out. So it is going in here, and it is coming out, right? And at this point also the current is upwards. It is going in, coming out. So outside the coil it is going in, inside it is coming out. Done? So again anti-clockwise inside the coil. Again inside the coil, the magnetic field will be towards outside, or will be outwards. Correct? The whole point. Understood the whole point? अरे यार तुम फिर शुरू हो गए, कहाँ से हो हैं? ठीक है, चलो, done with this. Then name two factors on which the magnitude of the magnetic field due to this coil depends. Now on what factor the magnitude of magnetic field due to these depend? That is, ma'am, first is current. For B, first is definitely current. As the current increases, the magnitude of magnetic field will increase. ठीक है? Then the second point is distance. As the distance increases, magnetic field strength will decrease. Done? Okay? And third is the radius of the loop. As the radius of the loop increases, magnetic field will decrease. Done? Understood? Everyone? ठीक है? Done? Okay, moving on to the next question. Answer the following questions. What is the direction of magnetic field lines outside a bar magnet? This is very easy. I have told you multiple times in this live as well. You tell me what is the direction of magnetic field lines outside a bar magnet. Let me know. What is the direction of magnetic field lines outside a bar magnet? किसका मैम? Hi everyone. Hi Deeksha, Ashish, Al-Razara. Sorry if I'm pronouncing, no, Fatima. I'll call you Fatima. Omni Creative. ठीक है? North to south. Karan is saying. Karan Singh Mohali. Are you from Mohali? So they are saying north to south. That is correct. Outside a bar magnet, the lines will go from north to south. From north to south. And inside, south to north. Inside, south to north. ठीक है? Done. The magnetic field lines in a given region are getting crowded. What does it indicate? There are two regions. This is the first region you have, and this is the another region you have. This is A and this is B. In which region the magnetic field lines are crowded? Obviously, ma'am, A. But what does it indicate? That in this region the magnetic field strength is more, right? The magnetic field strength is more. The magnetic field strength is less. Done? Understood? Strength of magnetic field. Very good. Done? Everyone? Okay, moving on to the next question. We have state one advantage of AC over DC. Can you guys let me know one advantage of AC over DC? High, low. What is high, low? State one advantage of AC over DC. Let me know. So AC current is something like this. See, AC is the one which do not has a constant magnitude. This is AC current, and this is DC current. It is something which has constant magnitude, right? This is DC, this is AC, right? Now what is the advantage? Ma'am, my name is Anjali and I am from Punjab. Hi Anjali, my name is Aditi, I am also from Punjab. Okay, moving on to, what did you guys know the advantage of AC over DC? So what happens is, we can transmit AC over large distances with minimal power loss. This is the main point, with minimal power loss, correct? Minimum power loss. On the other hand, if you see in DC, power loss is too much. Power loss is very high, and hence it is not feasible to transmit it from the nuclear power plants or wherever the electricity is being made to our houses, because a lot of energy will get wasted, right? Done? Okay. Then the next point is what? When a current flows through a straight conductor, a magnetic field is produced, okay, around it. How can the direction of this magnetic field can be determined? So this is very easy, ma'am. We know, we have studied a lot of time. We have studied a lot of time. The direction of magnetic field, can be determined by one very simple rule, that is my right hand thumb rule. Right hand thumb rule. Understood? That is right hand thumb rule. Done? Move on to the next question. Ma'am, light का होगा? Yes, light का होगा. The next chapter is light. ठीक है? Pole we don't have right now. I am really sorry for that, but we are working on that. We'll let you know. Hi, hello, Jagreet. Hi, Deeksha. Hi, Fatima. Whoever you are saying hi to, I'm just saying to you all, guys. Okay? ठीक है? Done? Can we move to the next question? Chalo. Which of the following statement is not correct about the magnetic field? This is the MCQs. Let me know the answer. Read it very carefully. I just have one rule in my life. That is, read the questions very carefully. ठीक है? Right now, you can take as much time as you want. First, we build correctness. Then we build efficiency. Okay? So, let me know the answer. बताओ, magnetic field lines form a continuous closed loops, or magnetic field line do not intersect each other. Intersect each other. Then direction of tangent or at any point on the magnetic field line curve gives the direction of magnetic field at that point. Okay, outside the magnetic field lines go from south to north. Pole of the magnet. Oh, let me know what is the correct answer. Yes, you will get the downloadable notes of this PDF. I'll give you with annotations so that you can have the answers as well. Okay, we are getting the answer as D, and Kailash is very correct. Of course, we know outside the magnetic field lines go from north to south. Not to south, not now south to north. That is inside the magnet. ठीक है? Done? Okay, let's move on to the next question. Next question says, complete the following ray diagram. Oh, we are on the chapter light. Whoever was asking, I think it was Ashish. Ashish was asking. So, Ashish was asking, I guess it was Ashish. Okay, so we are having this question where to get ma'am. Okay, so there is a link in the description. You can go join the WhatsApp channel and there you will get all the informations. ठीक है मैम, मेरा नाम तनीषा है. ओके ओके, हाय तनीषा. Okay, so complete the following ray diagram to show the formation of image. Formation of image we have to show. See, this is which mirror? This is now my convex mirror. Understood? This is my convex mirror and we have to complete this diagram. So let us complete this diagram. ठीक है, करें इसको अच्छे से करेंगे, आराम से करेंगे. ठीक है, we will do the ray diagrams very very easily. अरे यार, yes it is CBSE board, sorry for that, for CBSE boards. ठीक है, now see, there is an object and it is a convex mirror. Understood? In case of convex mirror we have only two cases. For convex mirror we only have two cases. The object is at infinity or the object is at any point between infinity and pole, right? So this is the second point, right? Here we have a second point. So what will happen? It is a diverging mirror. So if a ray is coming parallel, it will get diverged back and it will be diverged back and it will appear that as if it is coming from the focus. It appears that it is passing through the focus, and this is focus, not R. This is focus. Understood? Is this diagram completed now? Now where the image is formed? Ma'am, the image is formed at this intersection. The image is formed at this particular intersection and this red color is my image. Understood everyone? Kiya ma'am. Okay, yes, now very good. Whoever is saying, Karan Singh is, I am sorry I forgot your name, it must be Tanya or Tanisha, right? Okay, ठीक है? So mention the next. So first part is done, right? Mention the nature, position and size of the image formed in this case. Very good. Nature of this image is, see, nature of any image formed by a convex mirror. Formed by a convex mirror will be always it will be virtual and it will be erect and very important point, it will always be diminished, right? It will always be virtual, it will always be correct, it will always be diminished. ठीक है? Okay? Next, state the sign. Nature, position. Position is between, position of this image is between pole and focus, right? Between pole and focus of convex lens. Understood? State the sign of the image distance in this case using the Cartesian sign conventions. Now I have made a video for you guys. If you are confused between sign conventions, there is a video, it was just uploaded yesterday I guess. You can go watch them. I have explained each and every little detail, and if you watch that video, no one can stop you from scoring due to sign conventions, okay? So in this case we have, see here, this is my x-axis, y-axis let's say. So this is in here, the distances are negative, that is left hand side of the mirror. On the right hand side of the mirror, all the distances are positive. So now image is formed at left hand side, right hand side, right? So the image, the sign of image distance, sign of image distance will be what? It will be positive. Understood? everything? Okay. Oh, we have people from all the states now. ठीक है, everyone, Rajasthan, Uttar Pradesh, Karnataka, Punjab, everyone, the question is clear. ठीक है, let's move on to the next question, that is, oof, it's black. Oh, this is a good question. बताओ, ठीक है. Now, one portion of a convex lens is covered as shown. So we have a convex lens, then it is covered, one portion of this lens is covered. Yes, ठीक है. Will the lens produce a complete image of the object, or the lens will produce a diminished image or half image? Describe the characteristics of the image formed. ठीक है, बताओ, do you know what kind of image will be formed due to this convex lens? Let me know. Hello Muskan. ठीक है, चलो. So what happens is, see, there might be a confusion that if the part of lens or a part of mirror is covered, then maybe the half image will be formed, but that is not the case. Yes, Siddharth is right, brightness would be dull. Very good. So we have this convex lens, and let's say I have this object. So from this object, even at this tiny chotu part of this lens, all the rays from this lens will be going. Okay, from all the object, the whole object, rays will be going towards that chotu part of the convex lens, and then it will be making the image, right? But if all those rays were going at all the parts of convex lenses, again it would have made the same image. But the difference is what? Difference is size of the image will be full. Size of the image will not be impacted. Okay, will not be impacted, but image brightness of the image or dullness of the image will be there. The image will be, brightness will be less and image will be dull. It will be of less brightness. Hi everyone. आपका गोत्र क्या है? तुमको कुंडली मिलानी है यहाँ पे. आपका गोत्र क्या है? हाँ, ठीक है, पढ़ने पर फोकस करो. CBSE में नहीं आएगा कि उसका गोत्र क्या था. Yes, produce complete image with less intensity. Very good, Muskan. Okay, moving on, we have the next question, that is, the above image shows the formation of an image with an optical instrument. Okay, which type of lens is used in this diagram? Okay, let me know which type of lens is being used in this particular diagram. Batao, which lens is used in this diagram? Is it a convex lens or a concave lens? So it is very easy. अच्छी बात है, गोत्र मन नहीं पता तो भी अच्छा है. Yes, it is. Muskan is saying convex lens. Very correct. So for A part we can clearly see it is a convex lens, right? It is a convex lens. Second part says, what type of image is formed in the above case? What is the nature, what is the type of image that is being formed in this case? Convex, convex, convex. Okay, very good. Raju, Vaishnavi, Muskan, Karan, everyone is saying convex lens. Very good. Now let me know what is the type of image that is being formed in this case. Yes, the type of image is, first it is of same size. Very good. But it is also real. Well, that comes into nature, but you can write it. Okay, the type of image is real, inverted and of same size. Understood? Real and inverted and of same size. Very good, everyone, very good. ठीक है? Then what is the image distance from the lens? Now see it very carefully. What is the image distance of the lens? You don't even have to solve it. You can directly tell how, ma'am. See, the object is at 2f. The object is at 2f, right? And the image is also made at 2f. That means this 2f and this 2f is at same distance from the lens, right? So if this is 40 centimeter, this will also be 40 centimeter. So image distance will simply be plus, now plus 40 centimeter. Why plus? Because it is on the right hand side of the lens. Understood? Good afternoon, Pramod, sorry. ठीक है? Okay, 80, 60. Why 80? See, the object is at 2f1, the image is at 2f2. That means it is kind of similar to radius of curvature of our mirrors, right? So if this is 40, this will also be 40, right? It is same on both the sides. So yes, Vaishnav, it is 40. Vaishnav, whatever it is, it is 40 centimeter. ठीक है? Very good, very good. हाँ जी, फिरदौस बोलिए. Good afternoon everyone. How are you all doing? You had your lunch? हाँ जी, बोलो. Whoever is coming new, go like this session and go subscribe this channel. ठीक है? ठीक है, चलो. Next question. Very important. Oof, it is very important. We are starting with the numericals. ठीक है? Numericals start करते हैं. First is state two characteristics of the image formed in case of the mirror used by barbers. अच्छा, पहले तो ये बताओ which mirror is used by barbers. हो गया? Okay. Everyone had their lunch? हाँ. What is the problem? What happened? I am new. Hi, who was new? Muskan. It is our privilege to have you. We are working very hard for you guys for your class 10 boards, and I hope you give us the same effort. Okay? What should I explain? Yes, I'm explaining it. कितने क्वेश्चन रह गए? बहुत क्वेश्चन पड़े अभी तो, बहुत. आज सारी फिजिक्स खत्म कर देंगे. ठीक है? चले? So, state two characteristics of the image formed in case of the mirror used by barbers. Barbers want concave mirror or convex mirror. Break ले तो लिया था 5 मिनट. Yes, everyone is saying concave mirror. ठीक है? Sumit is also new. Welcome to the channel, beta. So, A is by barbers used concave mirror. Why they use concave mirror? Because see, whenever you go to a barber, you want to be like groomed, right? So you want to see those tiny makeup or tiny hairs of your beard, so that you can ask them to remove those, right? So for that we need to see an enlarged image, right? Enlarged image will be formed only by what? Convex mirror never forms enlarged image. It never ever forms enlarged image. But concave mirror is the one that can form an enlarged image, right? It can form an enlarged image. समझ में आई? Done? That is why barbers use concave mirrors. Now, real and inverted, of course, we don't know our chehra ulta in their mirrors, right? That is why, because the focal length of those mirrors, the focal length of the mirror used by barber is always more than the object distance, and the object is our मुंह. सही है, हमारा मुंह is the object, right? So we place our face between the focal length and the mirror. That's why it comes in the 6th case. ठीक है? Thank you, Firdaus. Really means a lot. ठीक है? Okay. Let's move on. Okay. Though we have a numerical here now. Numerical says for a convex mirror of focal length 30 centimeter. As we read the numerical, we write what it is given, especially in this case. So first write what mirror is given. So convex mirror is given, right? Convex mirror is given. Very good. Convex mirror is given and its focal length is what? Its focal length is 30 centimeter. Okay, and u is minus 50 centimeter. U is minus 50 centimeter. हो गया? Find the image distance. We have to find image distance. ठीक है? Let me see. Oh, I don't have an extra slide. इधर ही करना पड़ेगा. ठीक है? So what we have to do? We have F, we have U, we need to find V, right? And it is a mirror. Very carefully, mirror. So we'll use mirror formula directly. Correct? We'll use mirror formula. What is mirror formula? That is 1 by F equals to 1 by V plus 1 by U. Now 1 by F is 30 centimeter, and remember the focal length, the sign of focal length of the convex mirror is always positive. ठीक है? The sign of focal length is always positive. Oh, we have answers as 18.7. Right. Let's see what is the answer that comes. 1 by V we need to find, and then 1 by U, that is minus 50 centimeter. Okay, understood? Now let's see, when you calculate this, 1 by V is here and here is 1 by 30, and 1 by 50 goes there, there is negative, there will be positive 50, and when you take the LCM, this will be 150, this will be 5 plus 3 equals to 1 by V, that will be 8 by 150, right? That is 1 by V, and from there 1 by V is what? 8 by 150. So V will be 150 divided by 8 in centimeters, right? And what will you be getting if you divide 150 divided by 8? Yes, you will get 75 divided by 4, and if you further divide it, 4 will be 1 and 35, so that will be 8.75. 18.75. Understood? Everyone, this whole calculation, if you have any doubt in this, 18.7, yes, Muskan, you were right from the starting. ठीक है? 10 बजे से है मैम. Ashish is also been here from 10. So I want to appreciate you as well, not just me. नाम ले लो सभी को, नमकीन खिलाऊंगा. Okay. My voice is low. Really? For everyone? Yes. Just a minute. Let me check the voice. No, voice is right. Sunita, you can can you check your speaker or your volume once, because for me the voice is right. मैम ब्रेक मत लो. ठीक है भैया, ब्रेक नहीं लेंगे. चलो अगला क्वेश्चन करते हैं फिर. Okay, the next question, again a question from the chapter light. A spherical mirror has a radius of curvature of 20 centimeter. I will not take break, but you have to tell me that you are revising all these numericals by pen and paper with me. ठीक है? Now voice is clear. Okay, voice is clear. ठीक है. So a spherical mirror has a radius of curvature 20 centimeter. So radius of curvature we have is 20 centimeter. Done. Which is below in the diagram. Find its focal length. अरे इतना easy. We just know focal length is half of radius, so that will be 20 by 2 and that will be 10 centimeter. Very easy, understood? क्या हो गया? आवाज मुझे सही आ रहा है यार, आवाज तो फॉर मी आवाज इज सही. Yes, so that will be 20 सही तो आ रही है यार. 2 that will be 10 centimeter. फालतू मजाक कर रहे हो ना मेरे साथ, बहुत मारूंगी. अच्छा 3 बजे से क्लास है, ड्यूरेशन बता दो फॉर दिस लाइव. See, we are on the chapter light today, now, so we'll go till human eye and we are having, it will go beyond 3 probably. You can watch the recorded ones if you want. और बताओ, और क्या बताऊं? सब बढ़िया, आप बताओ. चलो फिजिक्स का बताते हूँ. हाँ, तो फाइंड इट्स फोकल लेंथ आ गया. आइडेंटिफाई द टाइप ऑफ मिरर दैट ऑलवेज फॉर्म्स डिमिनिश्ड, इरेक्ट एंड वर्चुअल इमेजेस. वेरी इजी. विच इज द मिरर दैट ऑलवेज, सी दैट ऑलवेज इज अ बिग वर्ड हियर, ऑलवेज फॉर्म diminished, erect and virtual image. So that is, my friend, that is convex mirror, because we know concave mirror forms real inverted image and it can form enlarged images as well, right? वॉइस अभी भी सही, अभी तो सही आ रहा है यार. भाई सुबह 10 बजे से 2 बज गए, थोड़ा तो एनर्जी लो होने का वो दो. लेट मी जस्ट ड्रिंक वाटर. अभी यू गाइज आर हियर विद मी, यू गाइज आर गिविंग मी आंसर्स एंड एवरीथिंग, तो हाउ कैन आई लीव, राइट? आई टोल्ड यू सारे क्वेश्चंस करेंगे तो सारे क्वेश्चंस करेंगे बस, ठीक है? डजंट मैटर व्हाट इट टेक्स. चलो करें. नेक्स्ट क्वेश्चन इट सेज, नेक्स्ट पार्ट इट सेज, स्टेट वन यूज ऑफ दिस मिरर, right? So ma'am, convex mirror we know it is used in rear view mirrors in vehicles, right? Understood? Everyone? अरे भाई नहीं करना रेस्ट. तुमको करना है रेस्ट. You want rest for 5 minutes? तो बताओ. Side rear view mirror of vehicles. Everyone. Very good. If you want rest तो बताओ. Instead I don't want rest. ठीक है, चलो. The next is, when light ray goes from one transparent medium to another transparent medium, it suffers a change in direction. ठीक है, it suffers a change in direction. No, नहीं चाहिए rest. Okay, fine. Let's do the questions. When light ray goes from one transparent medium to another transparent medium, it suffers a change in direction into second medium. Yes, that is true. We know that. That is the main thing of refraction. A light comes, this is the normal, and its direction is changed. Instead of going straight like this, it bends towards the normal, right? Which of the 3 parameters, frequency, wavelength and velocity, changes? Do you know which of the 3 parameters, velocity, frequency or wavelength, changes when light changes its medium? बताओ. Why are you crying, Ashish? Which of the 3 parameters stays the same or changes when light goes from one medium to another? So Muskan is saying velocity. Okay, velocity changes and what else change? Wavelength or frequency? One of those changes. So you tell me which one changes. हम तो बोले मैम. What? चलो बताओ बताओ, ठीक है. So definitely velocity changes. Velocity definitely changes when it goes from one medium to another, because we also have the formula, right? N1 by N2 is equal to V2 by V1. So in rarer medium velocity is more, in denser medium velocity is less, right? Yes, very good. Wavelength also changes. Second, wavelength also changes, correct? But frequency does not change. Frequency does not change because frequency depends on the source where this light is coming from. If this is coming from a torch, so the torch is the source and the frequency depends on the source. लो हो गया है, कहाँ लो हो गया है भाई? मुझे तो सही सुन रहा है यार. Why can't I feel कि लो हो गया है? Definitely changes when it goes from one medium to another. थप्पड़ मारूंगी अब इसके बाद, नहीं सुनूंगी कि लाइफ वो लो हो गया. चलो, next is a ray of light enters into the glass from air. Does it bend towards the normal or away from the normal? Does it bends? A ray of light, ये हमारा air है and this is glass. So ray of light is bending, is going from air to glass. It is going from air to glass. नहीं, it is, yes, it is entering into glass from air. Does it bend towards the normal or away from the normal? Tell me. Bends towards the normal. Yes, thank you. सही आ रहा है. हाँ, तो it bends towards the normal. This is my normal and instead of going straight, it will bend towards the normal. This is refraction. This is incident angle. Done? Okay. Subscribe the channel, like this session and follow the WhatsApp channel. The link is in the description. Like the session. Go, 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 go. Jaldi, jaldi, jaldi. Like the session and subscribe the channel. And और क्या था? Go join the WhatsApp channel. ठीक है? Because WhatsApp channel is very important. Subscription is also important. How will you see the videos? How will you get the notifications? But WhatsApp channel, do go join the WhatsApp channel. Now, the third is what? Light enters from air to glass having refractive index 1.5. So when light is entering from air to glass, its refractive index is glass air. That is 1.5. Done? Now, what is the speed of light in the glass? The speed of light in vacuum is 3 raised to power 10. So 3 into 10 raised to power 8 meter per second is the speed of light in the air. Now, refractive index of glass with respect to air is given, right? Okay. Yes, bends towards the normal. Yes, and share. Raju Gamer, very good. ठीक है. So, NGA is something. Refractive index is 1.5 given. Refractive index of glass with respect to air. Then V of A is given. We need to find V of G. Understood? Good. So let's see how we solve this. I just told you this formula here, right? This formula we saw. N1 by N2, V2 by V1, which is links the refractive index and velocity. So, N2 divided by N1 will be V1 by V2. Here we have glass. So, N of glass by N of A equals to velocity in the air divided by velocity in the glass. Correct? Ng by Na. Now, this whole term is given, okay? Remember, this whole term is given. कहाँ क्लास खत्म हो गया? बहुत गंदे बच्चे हो तुम. क्या? Yes, very good. The people who are studying, let them study. So this whole is 1.5 and VA is 3 into 10 raised to power 8 divided by VG. Now from this we can just cross multiply and see that VG is 1.5. No, VG is 3 into 10 raised per 8 divided by 1.5. Correct? So this will be 2 into 10 raised per 8 meters per second. Do not forget to write the units. Your pen will not do such kind of thing that my stylus did. Okay? Okay, done. क्लास मत ख़त्म करो, मैं थोड़ी देर पहले ही आया हूँ मैम. नहीं ख़त्म हो रही बेटा क्लास, अभी वी आर डूइंग द क्वेश्चंस. ठीक है, आपका वॉइस पहले तो अच्छा था तो बहुत बोला ना अभी. ठीक है, पढ़ने आए हैं ना, कि मेरी आवाज़ सुनने थोड़ी आए हैं. डिफाइन द फॉलोइंग टर्म्स इन द कॉन्टेक्स्ट ऑफ अ डाइवर्जिंग मिरर. व्हाट इज अ डाइवर्जिंग मिरर? Diverging mirror is the one which is concave or convex. Diverging mirror is a convex mirror. ठीक है, diverging mirror is a convex mirror. ठीक है. Now we have to define its principal focus. So principal, this is my convex mirror, right? This is my convex mirror. Now when I see this convex mirror, this is the principal axis, right? And this is its focus, this is its center of curvature. So this focus, we have to define the principal focus. So principal focus of a diverging mirror is a point where when a light ray comes parallel to the principal axis, when a light ray comes parallel to the principal axis, it will appear and it gets diverged, right? This one gets diverged back, but it appears to be coming from a point, and that point, my friend, is called focus. Understood? That point is called focus. Done? Okay, you are class 12. Okay. Bye bye. Hi, Pasha, new student. Okay. Then we have to define the focal length. That is simple. Focal length is nothing but the distance between principal focus and pole of the mirror, of the diverging mirror. That is my convex mirror. Line joining the center of curvature and pole of a spherical mirror is called principal focus. Yes. Huh? Sorry. No. It is not the line joining the center of curvature. That is not principal focus. You can say that is focal length. Right? Not even focal length. Half. Don't write like that. Just the line joining the principal focus and pole of the mirror is called focal length, and that length is called focal length. Yes, image is formed behind the mirror. Correct. So this exactly where it looks like coming from, right? So image is formed behind the mirror. Principal focus is the point from which it appears that the ray is coming from, or the light is coming from, when the incident ray is parallel to the principal axis of the diverging mirror. Understand? Understood? Chalo. Draw a label diagram to illustrate your answer. Ho gaya. Done? Okay. Also, you guys also use scales to draw these things, right? Okay. Draw a ray diagram for showing the convergence of a parallel beam of light by a concave mirror and the positions of pole and center of curvature in it. Okay. So, let us just draw. This is my concave mirror, right? This is my concave mirror. Do not forget to shadow this part, because that's how we will know which part is reflecting, right? Now this is the principal focus, right? So what happens is we have to showing the convergence of a parallel beam of light. So a parallel beam of light is coming. It should be parallel to your principal axis. What will happen? Now, where is the focus? This is the focus, and this is the center of curvature. So this parallel beam of light hits the reflecting part of the concave mirror, Focus on your goal, brother and sister. Very good, Raju. I'm proud of you. Okay? Now this passes from focus. Whatever ray that is coming parallel to the principal axis, every ray will pass from the focus. Understood? Every ray will pass from the focus. Understood? Every ray will be passing from the focus. This is something, what you will make this diagram. Understood? Understood? Okay. Then the next, we are done with this question and moving on to the next. So the position of pole is definitely at this point. This is the pole of the mirror, and center of curvature is double of the focal length. Okay, let's move on to the next question. An object 4 centimeter in size. An object 4 centimeter in size is in front of a concave mirror of focal length. Okay, an object 4 centimeter in size is placed at 25 centimeter. As you read, you write. The object is 4 centimeter. So height of object is what? It is 4 centimeter. Is placed at 25 centimeter in front of a concave mirror. Now we will write everything that is given in this question. So is placed at 25 centimeter. So U is 25 centimeter and U is always negative. Understood? U is always negative. At what distance from the mirror should a screen be placed in order to obtain a sharp image? That means at what distance the screen will be placed? That means we have to find image distance, nothing else. Image distance. Find the nature and size of the image. So we also have to find the size of the image. Let's just say we have U, we have V, we have height of object. See, from here we can find, focal length of this mirror is also given, right? That is 15 centimeter. Now the second thing after writing everything down is to see the sign of focal length. Hi, Kailash. Thank you. That means a lot. Okay, we are all trying our best. So for concave mirror, my focal length is always, negative. Focal length is always negative, right? Now, from I have focal length, I have U, we can find the V, definitely we can find V using mirror formula. Using mirror formula, we can find 1 by F equals to 1 by U plus 1 by V. 1 by F is minus 1 by 15, 1 by U is minus 1 by 25, this is also minus, okay, plus 1 by V. Now this 1 by V, it goes into this side, this will be plus 1 by 25. Understood? Now if you take the LCM, what will happen? 15 and 25 LCM will be simply 15 and 25 LCM will be 75. Okay, 15 and 25 LCM will be 75. Hi, namaste, Irfan. Okay, ठीक है? तो देखो, this is 75. So 15 into what? 15 into 5 will be 75. That is minus 5. Plus 25 into 3 will be 75. Just take the LCM, practice the calculation. You will also be able to solve this very quickly. Okay? Okay, so this is 75 and this is minus 2, 1 by V. So 1 by V is minus 2 by 75. So V is what? V is minus 75 by 2, and V, if you cut this, this will be 3, 6, 15, 7.5. Okay, so this is minus 37.5. And this is in, remember the units, these are in centimeter, you have to write centimeter. If you write meters, that will cut your marks, right? 37.5 Raju. Yeah, okay, done. So we are done with the position of the image. Find the nature and size of the image. Now nature of the image and size. For nature and size you have to, yes, minus is there for nature and, acha, you are telling me, right? For nature and size of the image we will find magnification. Now see, all these things are given to us. What is given? Height of object is 4 centimeter. U was given as minus 25 centimeter. We found out was minus 37.5 centimeter, right? V was minus 37.5 centimeter. And now you know the formula of magnification. Yeah, very good. Yes, you need to revise it again and again. That's how you will get ahead of the game. कोई बात नहीं राजू, it's fine. ठीक है, चलो. Now you know the formula of magnification. There are two formulas of magnification. That is what? Minus V by U, but it is also equal to height of image divided by height of object. Correct? Done. So I can just write, I have V, that is 37.5 minus, and one minus is already here, so divide by U is minus 25, correct, equals to height of image. We need to find height of image, right? And height of object is given as 4 centimeter. Done? Understood? H by H. ठीक है. So if you just multiply these two, now see, 37.5 divided by 25 is a tricky calculation. So what you have to do here is, you have to think, see, 25 and 375 looks like something that can get cancelled out, right? So 25 into 10 will be 250, so it is definitely more than 10. So you just have to like know now the trial and method, right? So it will be 13. If you multiply by 13, if it's more or less, you can, once you start practicing, you will realize how to do it. Okay? Yeah, very good, Karan. The formula is correct. Okay. So this goes to, if you take this point out, this will be 250. So height of image will be 375 into 40 into 4, into 4 divided by 250, and this 25, see, 25 15s are 375, and since there is 1 0, so it will be 1.5, so it will be 1.5 into 4, and 1.5 into 4 is simply 6 centimeter. This is 6 centimeters. Understand? मैम जाने का मन नहीं कर रहा है तो मत जाओ, अभी ना जाओ छोड़ कर. ठीक है, चले. Okay, next is, we found the height of image. Now the magnification comes out to be what? If we see, the magnification is simply height of image by height of object, and that is 1.5, correct? So if magnification is 1.5, that means the image is enlarged, right? The image is enlarged, and the image is, wait a second, is there any thing? Oh, we have forgot this minus sign. See, we have forgot this minus sign. This will be here, this will be here, minus 6 centimeter, minus 1.5. Now it will be real and it will be inverted. Understood the whole part? ठीक है? Done? Okay, moving on to the next question. Let's pick up some speed now. It's been so long. Draw a ray diagram to show the path of a ray of light falling obliquely on one of the refracting triangular glass prisms. Refracting triangular glass prism, and mark the angle of deviation. Okay? So, do I have a triangle? I have a triangle, but you have to make with your hand or scale you have. Now, this is a incident ray of light that is being incident at any angle on the refracting surface of the triangle, right? It is being incident somewhere here, right? Now what will I do? I will make a normal at this particular point. I will make a normal at the point of incidence. ठीक है? क्या कर रहे हो? ठीक है चलो, you guys continue your talking as well as you guys. I know you guys are studying, so I won't say anything. So now as the outer is rarer, the inside is denser and the outer is again rarer, right? So as the ray is going from rarer to denser, it will bend towards the normal, right? It will bend towards the normal. सब पिछले वही लोग आ गए जो पहले ये कर रहे थे ना, इंस्टा आईडी दे दो, ये है वो सब लोग वापस आ गए. ठीक है, चलो कोई बात नहीं. ठीक है, चलो अब at this point again you will make a normal, because on this point the ray is also going outwards. It will go from inside of the prism to the outside. Now it is going from denser to rarer, so it will bend where? It will bend away from the normal. It will bend away from the normal, and this is something what your diagram will look like. Hi Nagma. ठीक है, understood? Now they have asked us to mark the angle of deviation. Angle of deviation कैसे mark करेंगे? What you have to do? You have to extend this. You have to extend the incident ray towards its initial direction. Let me change the color. You have to extend the incident ray in its initial direction where it was meant to go. Then you have to extend the emergent ray back to the direction where it looks like it is coming from, right? Then this angle, the angle between incident ray, this one, and emergent ray is angle of deviation. Understood? This is angle of deviation. Understood everyone? Okay, moving on, we have what happens when a ray of light falls normally on the faces of a rectangular glass prism. See, these diagrams are very important. That's why I am spending so much time on these. I am spending so much energy on these, and I want you to make this with your scale and pencil and pen, all that stuff. Okay? Yes, angle of deviation. Hi Sarada Matam. I'm sorry if I'm pronouncing your name wrong. Okay, let's see. Now we have now in last case we had a prism. In here we have a rectangular glass prism again. Okay, oh, this is normal, right? If what will happen, they are asking, if now that ray that was being incident on the prism, what happens if it is incident on normal? So what happens, this is normal, right? Something like this, let's say something like this. Okay, so it is getting incident something like this. It should be normal, right. Here it is getting incident. Okay, now what will happen? Ma'am, we know a very important step. Whenever the incident angle is 0 degree, that means normal. Whenever the incidence angle is 0 degree, there is no refraction. No refraction happens when the incident angle is 0 degrees. ठीक है? Understood? Right? So this ray will go straight. This ray will not bend and will continue its path straight. Okay? But now on this surface it is not incident normally, it is incident at an angle. So we'll make a normal, we'll make a normal at this point, right? And from here it will bend away from the normal. It should go like this, but it will go even more like this. So this is my emergent ray, this is incident ray, this is refracted ray, although there was no refraction, and this is the angle of emergence. Understood? Understood? This is a very important question. This was never asked before, right? Let's move on to the next question. Okay, hello Devyanshu, hi, very warm welcome to our channel. We are going live for 100 almost PYQs of physics and we have completed the chapter electricity and magnetic effects of electric current, and we are now on the chapter light. Okay, ठीक है. Mirror X, okay, इसका जवाब दो पहले. Mirror X is used to concentrate sunlight in solar furnace and mirror Y is fitted on the side of the vehicle to see the traffic behind the driver. Which of the following statements are true for two mirrors? The image formed by mirror X is real, diminished and its focus. The image formed by mirror Y is virtual, diminished and direct. The image formed by X is virtual, diminished and direct, and the image formed by mirror Y is real, diminished and at its focus. Ma'am, I can't understand this question. This one or the previous one? Mariam. Which question? This one or the previous one? Yeah, Raju is saying concave mirror. Okay. Hi, Abhikishan. Next video will be, now we are putting out videos for rapid revisions, quick summaries, most important questions in live. Hi Shweta, hi everyone. अरे तो उनसे ही जाके पढ़ लो ना. He is a very good teacher. I really admire him. ठीक है, चलो. So the first thing is, first mirror is used to concentrate sunlight. So a mirror that is used to concentrate sunlight is a concave mirror. It is a concave mirror for solar furnaces. Okay, for solar furnaces, which mirror is used? Concave mirror. Second mirror is convex because it is a rear view mirror, and I've made a very cool short for you guys. Even you can go check that out where I explain why exactly that the rear view mirror is a convex mirror. ठीक है, this is sample paper exactly नहीं है, but this is all PYQs. This is all the PYQs of all the chapters of last 7-8 years. ठीक है, चलो. So concave mirror forms real, inverted and all sizes images, right? All sizes of images. But convex mirror always forms virtual, it forms virtual, erect and diminished images, right? So now tell me which option is true among these 4-5 questions. Option A is true. Devyanshu is saying the image formed by X is real, diminished and at its focus. That is true. And second is the image formed by mirror Y is diminished, virtual and direct. That is very, very true. So the correct option is option A. ठीक है? Let's move on to the next question. That is, the numerical value of the focal length of two lenses A and B are 10 cm and 20 cm respectively. ठीक है? Which one of the two will show higher degree of convergence or divergence? Lens with focal length 10 cm, lens with focal length 20 cm, both will converge the light with same degree. Let me know which one is true, which option is true. Which of these options is true? Let me know. Jaldi, jaldi, jaldi. Which option is true? Just मुझे पढ़ाई पे था, इन सबको इग्नोर करो. Okay, Raj, listen to your seniors. ठीक है, राजू. ठीक है, ऑप्शंस आर बी. मैम मेरे प्री बोर्ड में 70 मार्क्स आए हैं, क्या मेरे बोर्ड्स में 90+ मार्क्स आ सकते हैं? सी, एट दैट टाइम यू प्रोबेबली डिडंट हैव एनी रिवीजन फॉर द क्वेश्चंस. दैट्स व्हाई वी आर फोकसिंग सो मच ऑन क्वेश्चंस. व्हेन यू स्टार्ट रिवाइजिंग क्वेश्चंस, you revise the same question again and again, it's fine. But revise the same questions again and again. That's how you get engraved them in your brain, and even if a slight different question come, you will be able to solve this. ठीक है? Okay, I gave you the answer. Okay, ठीक है. चलो, what is the answer to this? Someone was saying option B or option A. We need higher degree of convergence. The option was A. Yes, very good. The option A is correct because the focal length, this has 10 centimeter focal length and this has 20 centimeter focal length. So of course it will diverge or converge the rays highly at a single point on a big angle. Okay. Ma'am, can you block the spammers? Okay, let me ask you. I have we do block the spammers, but sometimes it makes a fuss. ठीक है, चलो. Next question. Complete the following circuit and show the formation of image. Is this the same question that we did before, right? Mention the nature. ठीक है. Let's do it again very quickly. ठीक है? That is what I meant when we say कि revise the question again and again. चलो. So complete the following ray diagram. Now this is a which mirror? This is clearly a convex mirror. Done. Now as it's a convex mirror, what will happen? The rays will diverge. This is a focus. This is focus and not R. So what will happen? This ray is coming parallel to the lens, right? Parallel to the mirror. So what will happen? It will diverge on the back side. It will diverge and it will appear like it is coming back from the focus. And it will appear like it is coming back from the focus. Why it is not moving? Chalo. It is coming back from the focus. That is how we complete our diagram. ठीक है मैम, आपके पास SST के लिए कुछ बताओ. Very tough of the Gujarat board. See, SST, we also have lectures of SST on our channel as well. Tanvi ma'am teaches really great. You can go watch her lectures. We even have like quick summary, 10 to 12 minutes. So you won't have to spend so much time on the revision, but you can go watch that, okay? Okay. मैम ऐसा कोई न्यूमेरिकल जो सॉल्व ही ना हो. आप बताओ, यू गिव मी द न्यूमेरिकल व्हाट दैट यू कैन नॉट सॉल्व एंड विल सॉल्व दैट टुगेदर. ठीक है? Yes. So Karan is saying the position is yes. So the image for convex mirror is always virtual. It is always diminished and it is always erect. Right? It is always erect. Very good. Now state the sign of the image distance in this case using the Cartesian convention. We have to know the sign of image distance. Sign of image. Now ma'am, in case of convex mirror, we know image has only one sign, that is positive. Image is always formed on right hand side of the mirror, and that is why the sign of image is always positive. Yes, I'm sorry, your name is Anjali, right? A uniform wire connected directly across a 220 volt line produces heat H per second. The wire is divided into n parts, all the parts are connected in parallel across a 220 volt. The heat produced. Yeah, let me come back to you. We'll solve this and we'll solve your numerical as well. Okay? It simply uses the formula of heating effect of electric current. Right? In one case, a uniform wire is connected directly with the 220 volt and produces heat. Right? So heat is given, V square by R into T is given. If the same wire is divided into n parts, but the voltage will be same in all the parts, right? So voltage will be 220, correct? But its resistance might change and all. I think your question is incomplete. If it is divided into n parts, all parts are connected in parallel. Okay, let us look into this. मैम कोई नहीं पढ़ता है SST का, सब CBSE पढ़ाते हैं, हम लोग का SST अलग है. अच्छा, ओके यार, देन दैट मतलब you have books with you, right? Is that difficult from books? और बताओ आप सब दिख जाना. मैं तो 10 मिनट में ओके भाई. ओके, हेलो कैलाश ब्रो, SST के बारे में you are a senior. हाँ बताओ कैलाश ब्रो. कैलाश ब्रो is a sis. she's a sorry. Chalo, next question. A convex mirror used for rear view on an automobile has a focal length of 30 meters. We have a convex mirror, right? We have a convex mirror and its rear view on a automobile, and its focal length is what? Its focal length is 30 meters, right? And for convex mirror, focal length is always positive, right? Is located at 60 meter from this. Now, if a bus is located at 60 meter from this mirror, that means that bus is what? That bus is my object, and object is always taken as negative. Use mirror formula to find the position of the image of the bus as seen in the mirror. We need to find the V, right? Okay, very easy. Let's do it. Chalo. So, let us use mirror formula. Mirror formula is what? 1 by F equals to 1 by V plus 1 by U. Focal length is given, that is 1 by 30 meters equals to 1 by V, that is we have to find, and plus U is minus 60, right? This will be 1 by 30 plus 1 by 60 equals to 1 by V. If you just take the LCM, this will be 2 plus this will be 1 equals to 1 by V. This will be 3 by 60, 1 by V, and V will be 60 by 3, that will be 20. What are the units? Now this time it is meter, right? This time this is meter. This is our final answer, okay? And for convex mirror, image forms on the right hand side of the mirror, and that is why image distance is always positive, and with our calculation it is always positive. ठीक है? Okay, समझ में आ गया? क्या चल रहा है मोहित भाई? मैं नहीं मानता इतनी प्यारी लड़की सिंगल, हाँ? छोड़ो, चलो. Draw a ray diagram to show the image formation when the object distance is nearly equal to the radius of curvature of the mirror. Draw a ray diagram to show the image formation when the okay, curvature of the mirror. So we have to draw a diagram. Let's just say in this case we have concave mirror, right? And of course we will have concave mirror, because in case of convex mirror all the images will be formed between pole and focus if the object distance is at any point between infinity and pole. So that doesn't matter if it is it radius of curvature or not, right? Okay, now let us draw this diagram. This is my principal axis. Now let's say this is focus and this is radius or center of curvature, right? Now let us see how the rays are coming. Now draw a ray diagram to show the image formation when the object distance is nearly equal to the radius of curvature. So my object is placed at the center of curvature, then only the distance will be equal to radius of curvature, right? Right? Okay, chalo. Now a ray parallel goes to the parallel ray will go, that is parallel to principal axis a ray will go, right? And it will reflect and it will pass from the focus. Understood? It will reflect and it will pass from the focus. Now what you have to do? Technically we know another ray will go from the focus and will go parallel, but this is a trick. You have to draw the image first, right? We know image will be formed on the center of curvature as well. सही? ठीक है? चलो, तो this is again the image, right? This is again the image. Why I want you to make the image first? Because that will help you make the diagram easily. ठीक है? Now another ray. Now from here, this, do this. Make a ray parallel that goes to the mirror, right? Now from this point join the object, ठीक है, and you can shift your focus, ठीक है. अरे यार, चलो, done. This image is done. Very good. We made the image. The object is at radius of curvature. The image will also be at radius or center of curvature. ठीक है? Okay. Hi Rohit. Welcome back. How are you doing? चलो. Let's move on to the next question. A plane mirror is, oh, this question is good. Now Rohit will say, ma'am, this is Purana question. Because this is a very heavy question. You have to solve it, and this is a previous year question. ठीक है? चलो, a plane mirror is inclined to horizontal at 60 degrees. There is a plane mirror, and that plane mirror is inclined to horizontal. Let's just make a horizontal first. This is my horizontal, right? This is horizontal. Now a plane mirror. Hi Aditi Kumari. Hi, hello everyone, hello. So this is a plane mirror. Now this is horizontal, and a plane mirror is inclined to horizontal at 60 degree. So let's say now this is my plane mirror. ठीक है? This is my plane mirror. This is mirror. Okay? A ray of light is incident on the mirror at an angle of incidence 30 degrees. Let's just rotate this mirror a bit. Let's make this plane mirror something like this so that I can easily make the diagram. Okay, chalo. Now they are saying a ray of light is incident on the mirror at an angle of incidence 30 degree. Now before making the angle of incidence, the ray of incidence. Hi, my name is also Aditi Kumari. I am also Aditi. I am your physics teacher. ये सारे क्वेश्चन सैम्पल पेपर के हैं, PYQs के हैं. All these are from PYQs. ठीक है? Okay. Now listen carefully. Before making the incident ray, what you have to do, you have to make the normal to this mirror. ठीक है? The normal to this mirror will be something like this, right? It will be something like this. Correct? This is my mirror. This is my mirror. Okay, let me just shade it. This is the mirror, and it is inclined at 60 degrees from the horizontal. Correct? This angle is 60 degrees. Correct? Now see, now where we need a little bit of geometry. ठीक है? This whole angle is 90 degree because it is normal to the mirror, and this angle is 60 degree. So this angle will be what? 90 minus 60. 90 minus 60 will be 30 degrees, right? It will be 30 degrees. Now see, a ray of light is incident on the mirror at an angle of 30 degree. That means now this is my incident ray. This is my incident ray. That is why I was telling you to not make incident ray first. ठीक है? क्या हो गया रोहित? Why are you crying? अयो. ठीक है? चलो. Now angle, now we have to find the angle which the reflected ray makes with the horizontal. See, if this is incident, then this will be reflected ray, right? And if this is 30 with the normal, then this will also be 30, right? This will also be 30. The angle which the reflected ray makes with the horizontal is what? So this reflected ray makes with horizontal. We have to find the angle between these two rays. This one and this one, right? So this is 30 plus 30. So whole angle will be what? It is 60 degrees, right? It is 60 degrees, correct? So the correct option is option B. Only 2 MCQs will come is bar from physics. Yeah, you can say that because the sections are divided usually MCQs will be there, assertion reason questions will be there, everything will be there, right? चलो ठीक है, चलो next question. An object placed at a distance of 30 centimeter from the optical center of a concave lens. From the object is placed at distance of 30 centimeter. Now object distance is always taken as negative, right? From the optical center of a, now what we have guys, we have concave lens. Whenever we read a question, we write whatever it is given to us. ठीक है? Focal length is 20 centimeter. Focal length is 20 centimeter. Now, since it's a concave lens, for concave lens, focal length is what? Focal length is negative. Okay? Hanji Aditya Kumar, bolo. So, focal length is minus. Use lens formula to determine the position of the image formed in this case. We have to find the position of image, right? मैम मुझे इंग्लिश बोलना नहीं आता. It's fine. I'll ask you to watch some English movies. Srishti is saying bye. Bye. Hardest previous year paper, I will say, the one I have seen, it's not like the hardest, one is the hardest, but if you want, you can do what is, you can extract the hard questions from all the sample papers and attempt that. And one, I would say, don't just attempt the hardest one. Sometimes what happens is you know how to solve the hard questions, but you forget how to solve the easy ones. That does happen, trust me. So attempt all the sample papers, all the questions with full honesty. I know you'll be honest, but with full clarity and with full explanation and all. ठीक है? या राजू भाई थोड़ा प्रैक्टिस कर लो, हॉलीवुड मूवीज देखो, अच्छे से इंग्लिश सीख जाओगे. ठीक है? ओके, अब है इज बैक. चलो नेक्स्ट क्वेश्चन. हेलो गालिब साहब, गालिब साहब, हेलो गालिब साहब. इरशाद, सुनाओ कुछ. गालिब साहब सुनाओ कुछ. आई एम आयशा. ठीक है देन, ओके देन. चलो, सो यूजिंग लेंस फॉर्मूला, using lens formula, we have 1 by f equals to 1 by v minus 1 by u, right? So f is minus 1 by 20 equals to 1 by v is 1 by v, we have to find minus. Now here remember lens formula, we have negative sign, minus of minus 1 by 30. Done. So we'll just take the LCM. Minus 1 by 20, this is plus, and here it will be minus, and it will be 60, so that will be minus 3 minus 2 equals to 1 by v. So 1 by v will be what? It will be minus 5 divided by 60, so v will be minus 60 divided by 5, and then we will be minus 12. What are the units? Centimeter. Okay, not meters. Understood? Hi Maisha. SST का 4 बुक है ब्रो. हाँ, SST का 4 ही बुक है ना यार. यार तुम लोग का फर्स्ट चैप्टर क्या है? मैम, I am from IIT Kharagpur and give me some. क्या लिखा था? The comment went upstairs. Give me some tips to clear my backlog. अरे आई एम फ्रॉम IIT खड़गपुर. पढ़ो यार अच्छे से. इफ यू आर फ्रॉम IIT खड़गपुर तो खड़कते ही रह जाओगे बेटा. चलो डन. यस, ओके. नेक्स्ट क्वेश्चन. Path of a ray of light coming from air passing through a rectangular glass slab traced by 4 students as A, B, C, D in figure. Which of them is correct? Let me know which of the students is correct. Which of the student has traced the ray correct? Punjab. What is Punjab? Punjab is a beautiful state. Let me know the answer to this question. B. Rohit is saying B. Chalo. So B, yes, whatever a glass slab, whenever a ray passes from a glass slab, what happens? Whenever a ray is incident on a glass slab, we make a normal, definitely, and make it with a different color if you want. Array, sorry for that. ठीक है? So make normal with different colors. Even in your exams, I suggest you to make the normal with a different color, and I made it with the same color after telling you. So make normal with different colors. Now this incident ray, since this is air and this is glass, then it's air. So in the first case, the ray is going from rarer to denser, right? And then will be going from denser to rarer, right? Chalo. So it will bend towards the normal, right? It will bend towards the normal. Again, make a normal at the outside surface, right? Now here the ray will bend away from the normal, because now it is going from, here it was going from rarer to denser, right? Now it is going from denser to rarer. So it will bend towards the normal. Here it will bend away from the normal. This is incident ray, incident angle, refracting angle, emergence angle, and hence the diagram that matches with our is option number B. Chalo. Next question. The refractive index of medium. This is a very easy question. Now I am giving you the homework. This. ठीक है? Chalo. It's a very easy question, just basic maths. You have refracting index of medium X with Y, that is 3.2. Then refractive index of medium Y with Z, that is 3.4. You have to find the refractive index of medium X with respect to Z. तो ये तो बहुत ही easy है, ठीक है? Just solve this and let me know the answer in the comment section. Okay? Then this is the speed of light. We did it. The similar question we did it in this live. Okay? So go watch that. Ma'am, is this possible to get 90% in board examination in only 1 month? Dekho, it is hard, but it is not impossible, right? We are bringing you lives every day, so you can go watch them, practice the questions. Question practice will make or break your boards. ठीक है? चलो. Next question. I think we are on the chapter human eye, the last chapter of physics. चलें, चलो करो. ठीक है? चलो. Now, the first question it says, study the data given below showing the focal length of the 3 concave mirrors A, B and C and the respective distances of the objects placed in front of the mirrors. In which of the above cases the mirror will form a diminished image of the object? Where will the mirror form a diminished? This is the same chapter. Okay. We have a mirror and we have focal length in this case is 20 centimeter. Object is at 45 centimeter. Then another case, focal length is at 15 centimeter. Object is at 30 centimeter. Then another case, the focal length is 30 centimeter, but in this case the object is at 20 centimeter. In which of the above cases the mirror will form a diminished image of the object? So this is not the case because this is virtual. Erect and enlarged image, the 6th case, right? And this is what? This is at the center of curvature, right? Focal length is 15, object is at 30, so this will form the same size image. So first case will form the diminished image of the object. Understood? Understood? Clear? Thank you. Okay, thank you, Aditi. Ma'am, how much water need to be poured so that we can see an object placed in an opaque container? वाले questions in our syllabus. Okay, opaque container में कितना पानी डालेंगे? I have heard this for the first time, to be honest. I'll get back to you, ठीक है? I'll definitely search on this and I'll get back to you. चलो, list two properties of the image formed in second case. In second case, okay, in second case, the image is of same size. Why? Because focal length is 15 centimeter. That means radius of curvature or center of curvature will be 30 centimeter, right? And object distance is 30 centimeter. So whenever the object is placed on the radius of curvature or center of curvature, it will be of same size. Right? Then third is, what is the nature and size of the image formed by mirror C? So in C, we already see the focal length is greater than the object distance. That means that is the sixth case, right? The sixth case, and in that case the image is virtual, it is erect, and it is diminished. Right? So next question. A narrow beam XY of light is passing through a glass prism. Trace it on your, we have done it lots of times, ठीक है? So I am giving this as a homework to you guys, ठीक है? चलो, next question. This question is again refractive index, again your homework, okay? I've solved lots of questions for you guys, even the similar questions. छुट्टी बस थोड़ी देर में होगी. We are on to the last chapter, ठीक है? Maximum taken half an hour. चलो, it is observed that power of an eye to see nearby objects as well as far away objects diminishes with age. So, whenever the power, the lens, the eye cannot see, whenever an eye cannot see both nearby as well as far objects clearly, that defect is what? That defect is called presbyopia, and it happens due to the old age and gradual weakening of, it happens due to the gradual weakening of ciliary muscles, right? Gradual weakening of ciliary muscles. ठीक है? Name the defect. That is presbyopia. चलो. Next question is, what happens to the image distance in the eye when we increase the distance of an object from the eye? भैया देखो, ये तो बहुत ही आसान क्वेश्चन है. क्या करना है? चलो देखो, पहले ये देखो. So this is the distance of an object from the eye. देखो, this is eye, ठीक है? I was going to say my eye, but ये तो बहुत ही गंदी है. So this is the eye, ठीक है? And this is the whole eye. So this part is retina. So image distance is never changing from the lens. This is the image distance, right? From lens to the retina. Wherever the object is, doesn't matter. The focal length of lens will decrease or increase, but image distance will not increase or decrease. ठीक है? समझ आ गया? चलो, name and explain the role of the part of the human eye responsible for this case. The part of the human eye is, that is ciliary muscles. Understand? Understood everyone? चलो, next question. The focal length of a lens is 10 centimeter. ठीक है? The focal length of a lens is 10 centimeter. Write the nature of the lens and find its power. Very easy. देखो, focal length का sign क्या है? Positive. When focal length sign is positive, then it is a convex lens. Convex lens, convex mirror both has positive focal length. ठीक है? चलो. Then the nature of the lens will be convex lens, and find its power. Power is just one reciprocal of focal length, right? But it is in centimeter. Remember, we have to convert it into meter. So 10 centimeter will be 0.1 meter. Understood? 1 centimeter क्या है? 1 centimeter is, no, 1 meter is 100 centimeter. So 1 centimeter is 0.01 meter, and 10 centimeter will be then 0.1 meter. चलो, so focal length is 0.1 meter, and that will be 10 diopter. इतनी ज़्यादा power. So power is 10 diopter. खत्म? हाँ, आई डोंट नो, ये इनका अलग ही मीटअप चल रहा है. You haven't come in the morning. चलो. What is a rainbow? Definition is given, very easy. A rainbow is a natural spectrum of sunlight formed after a rainfall due to dispersion, internal reflection and refraction. This is my water droplet. ठीक है. Now इस water droplet पे ये white light, it incidents on the water droplet. Yes, 10 diopter. Karan, very good. Now I know it's not, Karan is not your name, I know, okay. Now what happens when this white light enters into the water droplet? It gets dispersed into its constituent 7 colors, and then it gets total internal reflection. It gets total internal reflection and then comes out, and we see it with the help of our beautiful eyes. ठीक है? Done. This is what is happening inside a water droplet, and we made the diagram. So first here it is happening refraction, then we see dispersion, right? Then we see total internal reflection, and then we again see refraction. Done? Chalo, moving on. We have the next question. Name the type of lens required by the person for the correction of the defect of vision called presbyopia. Nature of the lens is convex lens. Yes, very good. Chalo. So presbyopia, we have to say what type of lens. The type of lens that is used to correct presbyopia is bifocal lenses. These are bifocal lenses. What are these lenses? These lenses are something like this. So the lower part is to see or read. This lower part is to read the books or see the nearby images. This is a convex part of the lens, right? Convex part of the lens, and the above part is able to see distant objects, so that is concave lens. Okay, done? Chalo. Write the structure of lenses commonly used for this correction of this defect, giving reason for such designs. Understood, everyone? Chalo, next question. The image distance from the eye lens in the normal eye, when we increase the distance object from the eye. Answer me this question, jaldi. Sorry. Answer me this question, both myopia or hypermetropia, and using bifocal lenses, convex or concave. Very good, Raju. Give me the answer to this question. We have studied this question previously. Now it's just in the form of MCQs. It is also been repeated multiple times. ठीक है, चलो. Now the answer is, we know that whatever the object distance changes, the image distance does not change from the eye lens in the normal eye. When we increase the distance of object, it does not change. ठीक है, so it remains same. चलो, next question. After tracing the path of a ray of light through a glass prism for 4 different values of angle I, every ray diagram was analyzed and the following conclusions were made. On drawing the prism, the ray bends towards its base. See, this is a prism. A ray of light goes, it bends and it bends, right? Something like this. This is a rough diagram. On drawing the prism, the ray bends towards its base. Yes, definitely it is bending towards its base. First is true. While emerging from the prism, the ray further bends towards base. That is also true. B is true. The emergent ray bends at a certain angle to the direction of incident ray. The emergent ray bends at a certain angle to the angle of incident ray. That is also true. This is incident angle, so this is emergence angle. So it bends at a certain angle this is the at a certain angle to the direction of incident ray. So all these are correct, A, B and C. ठीक है, understood? चलो next question. Now we'll do just 2-3 numericals. ठीक है, those are left and we'll pack up this session. ठीक है, चलो. The near point of the eye of a person is 50 centimeter. What is given? The near point. Whenever in a numerical a near point or a far point is given, that is the image distance. Image distance of the corrective lens. ठीक है, it is very important. Image distance of the corrective lens. ठीक है, then the corrective find the nature and power of the corrective lens of required by the person to enable him to see clearly the object placed at 25 centimeter from the eye. So object distance is actually 25 centimeter. Image distance is again minus 50 centimeter. What is the nature of lens? Let's see. Now see, first without solving, this is a near point. Near point has shifted, and at which case near point shifted? In case of hypermetropia, right? Hi, good afternoon Abhay. ठीक है, so we'll use lens formula, that is 1 by V minus 1 by U. So 1 by V is minus 1 by 50 minus of minus 1 by 25. This is 1 by F. So 1 by F is 50. So minus 1 plus 2, this will be 1 by F is 1 by 50. So focal length is 50 centimeter. Now focal length is positive for which kind of lens? That is convex lens. Convex lens as well as mirror both has positive focal length. Done. And since we know it is hypermetropia, so to correct hypermetropia we do use convex lens, right? Chalo, next is a student needs spectacle of power 0.5 diopter for the correction of his vision. ठीक है, name the defect of vision the student is suffering from. देखो, power is minus 0.5 diopter. So whenever there is a minus sign, that means focal length is just reciprocal of power. So focal length is always also negative. Now focal length is negative for which kind of lenses? It is negative for concave lenses. ठीक है, it is negative for concave lenses. Done. Name the defect of the vision the student is suffering from. Now concave lens is used to correct which defect? It is used to correct myopia, right? It is used to correct myopia. Understood? Then find the nature and focal length of the corrective lens. Focal length will be what? 1 by focal. Now focal length will be 1 by 0.5 and that will be 2 meters. Done. List 2 causes of this defect. 2 causes of this defect is what? Elongation of eyeball. Elongation of eyeball. And second is decrease in focal length of the eye lens. Done with this question? Okay, bye. ठीक है, चलो next question. Oh, join the WhatsApp channel. Go join the WhatsApp channel, follow the channel and subscribe this YouTube channel, and you can join the WhatsApp channel using the link in the description and like this session. Jaldi karo, like this session. Very good. Fatavat. Like this session. Chalo. Moving on to the next, we have a question. Yes. A focal length of the eye lens increases when eye muscles become what? Done, ma'am. Thank you, Abhay. And My voice is gone. Abhay, thank you, Abhay. No, thank you, Galib. Okay, the curvature of the eye lens. What? Yes, very good. The curvature of the eye lens. The curvature of the eye lens. What? It increases or decreases? I am very confused in curvature. Focal length decreases, that means curvature increases. Okay, so curvature of eye length, curvature increases. ठीक है, चलो. The question is, the focal length of the eye lens increases when eye muscles do what? हाँ, really, thank you, Raju. चलो. Give me the answer to this question. The focal length of the eye lens increases when eye muscles. राधे राधे साक्षी, जवाब दो जल्दी. चलो देखो, the focal length of the eye lens increases. Eye lens focal length increases, that means eye lens becomes thin, right? If eye lens becomes thin, that means muscles are relaxed. That means muscles are relaxed. ठीक है? So what option suits best? Focal length of the eye lens increases when eye muscles are relaxed and lens becomes thinner. The first option is true in itself. ठीक है? चलो. With the help of ciliary muscles, the human eye can change its curvature and thus after the focal length, alter the focal length of the lens. State the changes that occur in the curvature and focal length of the eye lens while viewing distant objects. Very important question. Yes, A is the true part, everyone. True option. चलो, we have to see for distant object. देखो, for distant objects, अरे, for distant objects, देखो, U is more, right? Object distance is more, and you can remember from that for that focal length is also more. ठीक है? Focal length increases, and if focal length increases, curvature decreases, right? Curvature decreases. Done. And for nearby objects, correct? Now this is U is less, that means focal length is also less and hence curvature is more. Understood? ठीक है? Okay? चलो, explain why a normal eye is not able to see distinctly the objects placed closer than 25 centimeter. So there you've heard about the power of accommodation of the lens, but a thing can only be contracted till a certain point, right? If I keep trying to contract the lens, it will break, correct? That is why it has a limit on how much it can contract. The limit to which it can contract makes our near point as 25 centimeter. If it is placed at 15 centimeter, let's say, the lens needs to contract a lot, and if it contracts a lot, it will obviously pain us, right? ठीक है? Hello Himanshu. चलो. Next question. Ravi kept a book at a distance of 10 centimeter from the eyes. So Ravi kept a book at a distance of 10 centimeter from the eyes of his friend Hari. Hari is not able to read anything written on the book. Explain why. Hey, this is very easy. This is the same thing we studied, right? लेकिन मैं देखता हूँ तो दिखता है, ऐसा क्यों? दिखता तो है, but if you prolongly, like if you see to a distance like 10 centimeter you are reading, and if you keep reading it for a prolonged period of time, it will hurt your lens and it can even damage your eyesight. ठीक है? So don't do that. Yeah, exactly. The near point is 25 centimeter. The near point is 25 centimeter. So if you place a book near to the even closer to the nearer point, that will make the eyes hurt and we cannot read it properly what he meant is. ठीक है? Hello ma'am. Hello Vivek. Okay, चलो. Next question, the near point of a person suffering from hypermetropia is 75 centimeter. So the person is suffering from hypermetropia. Now what did I tell you? Every time a near point is given, that is our image for the corrective lens. That is our image distance for the corrective lens. So this is minus 75 centimeter. Calculate the focal length and power of the lens required to enable him to read the newspaper. So corrective lens, okay? So U is minus 25 centimeter. We'll just use lens formula, right? 1 by V minus 1 by U. We have to find the focal length and power. So this is minus 1 by 75 minus of minus 1 by 25. That will be 75 minus 1 plus this will be 3. So that will be 2 by 75. So V will now be 75 by 2. So V will be 37 point. Focal length. Sorry. Focal length is not the V. Focal length is 37.5 centimeter. And interesting fact, we know that focal length of convex. So hypermetropia is corrected by using convex lens, right? Convex lens, and we know the focal length of convex lens is positive, which we calculated by our answer. ठीक है? Hi Vivek. Ram Shankar. Who is Ram Shankar? Oh, ma'am, I'm suffering from myopia. Right, Ram Shankar. Sorry. Ram Shankar is suffering from myopia, so he is using concave lenses. Hello, ma'am. Sandhya. Chalo, next. What happens to the image formation on the retina in case of myopic eye? Image is formed in front of retina, behind the retina, or image is formed on the retina? Let me know the answer to this question. Hello Shubham. Let me know the answer to this question. Chapter 1 complete hai ma'am mera. Okay, that's good. You can like move on to another chapters, and you can also revise those chapters. Okay. Good afternoon. Anulata. Okay, chalo. In case of myopia, we use to correct. I'm just giving you random information. We used concave lens to correct myopia, and in this case the image is formed in front of the retina. The image is formed in front of the retina instead of on the retina. Understood? Then yes, everyone is correct. It is formed in front of the retina. KGOS. Sandhya. Yes, hi Sandhya. Anulata, sorry. What? Yeah, okay. चलो अजय कुमार. Hi Ajay Kumar. चलो, if an object is placed at a distance 20 centimeter from the optical center of this lens of focal length 10 centimeter, so we are given the focal length as 10 centimeter, correct? And the object is placed at 20 centimeter, so object distance is always taken as negative. According to new Cartesian convention, what will be the sign of magnification in this case? What will be the sign of magnification? Let's see. If the focal length is 10 centimeter, that means it is a convex lens, right? It is a convex lens. And in case of convex lens, we have magnification as both positive and negative. That is true, है ना? तो कैसे निकालेंगे? Yeah, so we will just find lens formula. We'll just use lens formula and we'll find V, and from there we'll find magnification, right? V minus of minus 1 by 20. So 1 by V will be 1 by 10 minus 1 by 20. That will be 20. 2 minus 1 equals to 1 by V. You have to practice this calculation, okay? So V is 20 centimeter. So magnification for lenses, we are using lenses here is V by U, not minus V by U, it is plus V by U, okay? so V is 20, U is also given as minus 20, so this cuts out and magnification is minus 1. ठीक है, the sign of the magnification will be negative. ठीक है, then क्या क्या, give the answer what that power of accommodation. Power of accommodation is just the ability of our eye lens to change its shape according to the position of the object. ठीक है, done. फिर से बताइए. Hello everyone. देखो, we are given with the object is placed at a distance of 20 centimeter, so U is 20 centimeter. From the optical center of this lens of focal length 10 centimeter, so focal length is 10 centimeter. According to the new Cartesian convention, what will be the sign of magnification? Now to find the magnification we need V, right? We don't have V. The formula of magnification is this, V by U. So we use lens formula. We use lens formula first to find the value of V. As we have the value of V, we put it in the formula of magnification. ठीक है, चलो next question. We have anything? चलो, this is your homework. ठीक है, all the other left questions are your homework, guys. I am a bit tired. Yes, true. चलो, now this question, just a few questions are left. This question, do it as your homework. Let me know the answers in the comment section. Take the screenshot. Then this question is assertion reason question. Chalo, homework. ठीक है? Then we have a question. Again, this is just normal question. Study the diagram. Name the defect of vision depicted in the diagram. क्या defect है? The defect is the image is forming behind the retina, right? The image is forming behind the retina. And in which defect image is formed behind the retina? In defect of hypermetropia. ठीक है? The defect is hypermetropia. What is presbyopia? Presbyopia is a defect in which a person is not able to see nearby as well as far objects clearly. Lens for correction is presbyopia. Lens of correction is bifocal lenses. ठीक है? चलो, next. Name the defect of vision depicted in the diagram, that is hypermetropia. How it can be corrected? It can be corrected using convex lenses. Easy, very easy. That's why I am giving you this as homeworks, right? Chalo, yes. This is you have to do homework. Okay, take the screenshot. Then that is it. I am thinking. Oof, again one homework. These are, don't worry, these are very easy numericals. I have done these kind of numericals in this session as well. Okay, so you can easily solve them. If you have any problem, I'll come live again, you can ask in them. ठीक है? Your homework. Then that is it, I guess. Human eye can focus on objects at different distances by adjusting the focal length. This is due to, this is very easy. This has different options. Okay, these options are wrong. So this is due to ciliary muscles. This is due to the help of ciliary muscles. ठीक है? चलो. Yeah, this was actually the answer. The change in focal length of eye lens is caused by the action of ciliary muscles, right? Okay. Oof, bus. And we are done with the live session. Defect बता दीजिए, कौन सा defect बताना दिलीप? Which defect you want me to tell? Hi खुशी. Welcome Khu. What is KHU? Sorry for that. ठीक है, चलो. Okay, we are done for this session. All of you are here. Please like this session, show some love, subscribe to the channel. There is a link down the description. You can go and follow our WhatsApp channel. ये वाली chapter easy लगती है. Yeah. This chapter is not much difficult, but do focus on the numericals, right? चलो, let's end this session. ठीक है? All the best for your boards. I will be coming live again with the full live again of MCQs. ठीक है? Do join that. We know this time MCQs is very important. चलो, okay, bye. Hi, Art by Shri. Bye. The session is ending. Electricity, we did that, Raju. Yes, class is over. Art by Shri. So the electricity we did in this live session. We are going live from 10 in the morning. So we did electricity first, then we did magnetic effects of electric current, then we did light, and then we did human eye. And in our total, I think we had 100 questions. We did 100 questions today. Okay? Thank you, welcome, thank you everyone for joining this session. I hope it helps your boards. Okay? Bye, tata. Meet me in the next live session. Okay?